Well, hello everyone, and welcome into yet another live stream. And yeah, I'm starting this live stream a bit early. This is a bit of an early live stream, but there's a reason for it. You see, it's just 5 more minutes. All I need, actually. so all I need is just like 5 more minutes tops. 5 more minutes tops, and then we'll be finished with the video. So yeah, like 5 more minutes. That's all we need today. That is absolutely all we need. Just 5 more minutes. And then the video will be finished. Done. There. No more. Right? So let's do it. Let's just do it. Just 5 more minutes. Okay? That's all we need. By the way, it's day 516 if I'm not mistaken. There we go. And so there we go. Yeah, okay. Yeah, I upgraded Premiere and now the colors are so ugly. Oh my goodness, that's bad. That's really bad. I don't know why that. Oh, that's awful. Wow, that's really okay. And also, the reason why I updated it is because it just keeps freezing every couple of seconds.
Entropy? That's cool, but what is useless energy? Well,
okay, yeah, this sound effect is pointless.
Imagine a hot cube, like
really hot, so a cube like this right here. Yeah, we're getting straight to it, because I mean we have work to do. We ain't got time for all of this. Oh, normally I would do label mango, but
cube, like really hot, scald.
Okay, right here we want a transition, cross dissolve. Why is the cross dissolve here? It should be at the center. Sweet.
Hot cube, like really hot, scalding hot. Then imagine placing an.
Alright, so what I need now, what I want now. Oh, my taskbar is broken already. Festive. No one's joined in yet, but that's fair. That is fair, I suppose. I'm gonna give it a second. Okay, hold on. Let me take this away. Open. No. Open with VLC. No, don't play it yet. Don't play it yet because we want to open multiple files. We don't want to open these files. There we go. Now we can play it. Sweet. Let's go for it then. Hey. Hey, alright. Para-para-pum. 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 Para-para-pum-pum-pum. Taskbar settings. Consider the settings taskbar. Also, let me check one more thing. Is it still loading? Give me a second. I just need one quick second. It'll be really quick. There we go. So, right here we have this, and then what we want is the generator. Now, in order to make the generator, I'm gonna open up Blender. There we go. And that will be the entropy, if I'm not mistaken. Right here, we're gonna switch it to the heat material. There we go. And now for the generator. So what you're making? Just 5 more minutes. All I need. I'm just gonna spend 5 minutes working on this video, and that's it. So that's what I'm making. I'm just gonna finish this video, and it will take just 5 minutes. 5 minutes. That's all I need. 5 minutes. Okay? 5 minutes. That's all I need. Give me a second. It's an Oscar make it. I'm holding an Oscar. Can you not see? Okay. Oh, what's up, Makey? I'm good. Just 5 more minutes, as I mentioned. That's all I need. That's all I need. That's all I would need ever. Okay, I'm fine, by the way. Hydroxobitant, I'm not watching the Euros because of my parents, but I'm here watching your streams. Hell yeah. Well, then you'll be here to see me make a video actually, and that's because I will make a video today. I will finish it. Definitely 100%, cause it's simple. All I need to do is just spend 5 more minutes on it. I just need to spend 5 minutes on the video, and then it'll be finished. All right. I'll just select this inside and there. That's precisely what I'm looking for. I don't think you'll be. Oh, you will be able to. Never mind. This is where it will end up. Let me delete all these frames. 100 and then 200 or 175. I know how much we can spare actually. That's where you end up. And then this, we want it to go inside and then in like this. Out and out. This to be more like a circle. That's circle-ish enough. And then what we need is a light bulb, which I also do have. I do remember specifically having a model of a light bulb. Because I'm just that well prepared. There we go. Is it an object? I think we'll need to add textures to it though, because I'm pretty certain I screwed those up. Oh, actually they, I think, came screwed up. There we go, comically large light bulb. Isn't that great? Okay. That's for Y, that's for X. Actually, we're gonna cover with X apparently. Oh no, this is X, oops, that was Y. There we go. Now right here is gonna go up. And right you want it to mount slowly. And then this, we would like to have its own animation, something like... Let's try quadratic. How would this look like? Okay. Okay, I like it, I like it. So we'll have it like this, and then what we need to do is we need to do the materials for the light bulb. Fortunately, he already has them. All we need to do is just find the appropriate ones and then do the thing. So first of all, this, which, if I'm not mistaken, is the base. No, this is the base. Okay, so we're gonna remove this and set up a clean principled. It's different than metallic, a little bit lower in the roughness. Sick. This will be the glass then, which means we remove it. And we add a new one, principled, actually glass. I feel like glass would be easier. With IQS to like this, I think. And then we remove this one, we set it to principled with right here. We want the temperature attribute. Wait, what? No, it's volume, never mind. I meant principled BSDF, there we go. Emission, I like 5. Okay, sweet. So now the glass is the problem. There we go. Maybe we can turn to more of a yellow light. Sick! Why is this yellow already? There should be absolutely no yellow light in it. Oh wait, no, I switched it to damn it, I'm an idiot. I switched it to a yellow glass, not a yellow light. This is what I meant. There we go. There, and this is supposed to represent the change of thermal energy into electric energy. I feel the caffeine and glucose kicking in from the coke I just drank. Well then, you know what, let me join you. Let me have a sip of coffee then. This time I added sugar to make myself drink all of it quickly. So, I think it's sucrose, right? I don't know, close enough. Some kind of sugar is there. Ah, the new Make It verse looks so amazing. This will stay up somehow all night together. Hell yeah! I mean, listen, this is gonna be a short live stream. This is gonna be a pretty short live stream because, like, just 5 minutes. That's all I'll need. This live stream will be like 5 minutes long because the entire stream I'm just gonna edit all of this. So like, just 5 minutes, okay? That's how long the live stream will be. So we know. Don't get your hopes up yet. It won't be all that long. Yeah, precisely. So we know. Oh, yeah, I might have, you know what, I am rendering that in the background. There isn't really a way for me to speed this up. Each frame will take a minute, so that's an hour. I have to wait. Cool, oh my god, such a long time. I need to get rid of that volume scene as quickly as possible and replace it with something that doesn't have volume. So right now we might as well edit all these.
Both of these cubes have their own mass. This cube is traveling at a certain velocity, so it has some...
By the way, I'm not pausing it, it just pauses itself. There's some problem with the Premiere. Premiere Pro keeps pausing. Let's fix it. Unplug all USB devices, then plug them one at a time. See what image of the cause preview to force pause. This is wild. This is wild. Hold on. Why is that a thing? So unplug. What? I didn't plug in anything new. I was just supposed to unplug random. There, consider yourself replugged. How is that even a problem? That's such an Adobe moment. Oh, this is such an Adobe moment. Okay, hold on. I need to switch my mouse sensitivity. There we go.
Sort of momentum. Irrelevant. Now when it hits this cube, it accelerates. And that's where our equation comes in handy. It basically says that the higher the force, the quicker
Okay, so
it
far it looks
accelerates.
good.
So the more
Did that fix it?
while accelerating, the shorter the time for a certain acceleration to occur, and the bigger the mass it can accelerate. That's why all the units are there. Now we understand force, we can get to walk.
Oh no, it paused again. Okay, good. So I just have to survive.
Walk. So what is walk? well, walk can be defined as distance push this cube over. Okay, well, it's not quite the distance itself, it's like the amount of distance the force acted on, so like how far we pushed. So force multiplied by distance, that's walk. So how far we pushed, but pushing is like a central part. It's force times distance. So imagine a make it intern pushing a cube. This
Okay.
make it intern is active.
Oh, hold on, I can also work on this in the meantime.
In order to understand.
Because we did render these cubes, if I'm not mistaken. So we'll just have to survive because it keeps pausing. And I can't really unplug anything because if I unplug stuff, I won't be able to use them. And the only USB things plugged into my PC are my keyboard, my mouse, and my microphone charging thing, and my headphones. And all of these are pretty crucial. So cool. Thank you, Adobe, for providing us with such amazing products. Lovely. And so if I'm not mistaken, this is the one, the cubes, correct?
Standard, we have to imagine two cubes. First one bumping into the other one. Both of these cubes have happened to the other one.
It's a bit too low.
In order to understand that, we have to imagine two cubes.
Okay, so right here we want to push the first one into the other one. Simple as it could be. There we go. So this one we want to push right here. There we go. Another bounce on the bezier, and this one as linear. No, this one is linear. Fine, this one is linear. Guess we have to be closer to it. There we go, and right here, this one will just go off the side. The problem is we can't really. It's a momentum because we. I'll actually have to. Yeah, because now this one speeds up. That's how professionals do it. They just do it manually and they keep checking if it works. There we go, good enough! That's what I'm gonna call it. Law of conservation of momentum? Yes. Well, it's actually conservation of kinetic energy. That's kind of fun. Momentum bit. I should move it up. We have still this remaining. So like this, and then you move out the way. And this one will also take hours to render because. Just 5 more minutes, make it. You can do it. Just 5 more minutes. All you need. That's all you need. Just 5 more minutes, and then you'll finish the video. Okay. Yeah, okay. This one also takes a minute per frame, which means over an hour. Cool. How's this one doing? Minute and a half now. Huh. Great. Great. Sweet.
This one bumping into the other one. Both of these cubes have their own mass. This cube is traveling at a certain velocity, so it has some sort of momentum. Now when it hits this cube, it accelerates. And that's where our equation comes in handy. It basically says that the higher the force, the quicker it accelerates. So the more meters it can cover while accelerating, the shorter the time for a certain acceleration to occur, and the bigger the mass it can accelerate. That's why all the units are there. Now we understand force, we can get to work. on understanding walk. So what is walk?
Okay, right here we'll have
walk
the
can be
intern
defined as distance we push the
pushing.
over. Okay, well, it's not quite the distance itself, it's like the amount of distance the force acted on, so like how far we pushed. So force multiplied by distance, that's walk. So how far we pushed, but pushing is like
I really like this bit.
essential part. It's force times distance.
Okay,
Distance.
then we have this right here.
So imagine a make it intern pushing a cube. This make it intern is actively walking, which means that the walk is being,
Okay, right here, this we can cut.
which means that the walk being done is equal to the force of the intern pushing
Times the
multiplied
distance.
by the distance
Yes.
the intern is covering. But how does that relate to energy? Well, energy is the capacity for walk, which means that in this case, this is the equation for energy. Kinetic energy of this cube. Now this example is a bit tricky because we have our make it and then pumping new kinetic energy into our system by pushing the cube. And the cube is losing the energy as thermal energy because of friction, but that's the equation for kinetic energy of the cube. So the work it's doing. Now it's time for the electrical energy equation.
Yeah, and right here we'll be switching between energy. Switching it will be a bit nicer because for switching we have a lot of it done. Okay, so this is what it looks like now. Now we're gonna get really into editing and we're really gonna speed things up. Hold on, give me a second, let me just... I need someone as moral support for this because I'm about to have a... Oh boy. Just 5 more minutes, make it. You can do it. I believe in you. So by the way, half of it is done only. Only half of it is done. So we're about to finish the other half. The half of it took me, what, 4 weeks now? And we're about to finish the entire other half on a single stream. I mean, of course we are. It's only gonna take 5 minutes, so why wouldn't we? So quick.
And the cube is losing the energy.
Okay, it's right here with electrical.
And so for electrical energy, we're talking about
So, electrical energy. I also rendered another thing, which is this. This last stream rendered all of them.
electrons and their movement. So for electrical energy, we're going to start with this. I won't re-explain how to get
Okay,
this equation.
let's just mark
here
all the
because
energies.
That's the story for another time and another video. So for now, we will just have to trust me with this equation. An equation which says that the velocity of our electrons is equal to the charge multiplied by the magnitude of the electric field per mass times time.
Okay. So yeah, this is the electricity, cool.
Okay, the point is if we divide both...
I think my mouse is glitching, Premiere. Or rather, Premiere is getting glitched by my mouse. Not really my mouse's fault, it's Premiere's fault.
by time, we'll get acceleration equal to this. And if we multiply both sides...
Hi there,
by mass,
guy,
we'll get
welcome.
force equal to this. I think you can see where this is going. Back in the classical mechanics...
Okay.
Back in the classical mechanics, we took the force acting upon an object, multiplied by distance, and got the work done. We can do the same thing here, so we can multiply it by the distance and turn this magnitude electric field into voltage. Now we get the energy equal to voltage times charge. What does that mean? Well, imagine a magnet. Does that mean? Well, imagine a magnet. What this equation says is that the stronger the charge of the magnet, or the stronger the potential acting on it, the more electrical energy it has.
Alright, there we go.
That's what happens in our cables, except instead of our magnet we have electrons, so that's electrical energy. Like magnetism, whole other kind of words. The point is, that's electrical
Okay.
energy. Next we have... Alright, remember what I said about the radiant energy?
So there we go. This is a radiant now. Sweet. So that's the radiant we rendered.
Alright, remember what I said about the radiant energy being related to the wavelength? Why is that? Well, let's go back once again to kinetic energy and its equation of ms squared divided by t squared.
By the way, anyone feel free to chat. I know I'm not I know I'm really locked in right now, as kids these days would say, but I just want to get this done because, like, I just 5 more minutes and we're finished. So, you know, 5 minutes precisely. All I need is 5 minutes, I guess. All I need. How did we make it? Hi, the Tefta. How you doing? How did I what? Are you an Oscar make it now? Yes, I am an Oscar make it. Yes, I am. Not interactive chat. Oh yeah, I'm so sorry. How awful of me as a streamer. Hi, Tefta. Hi. You're in the zone. I mean, I'm not really in the zone.
Now we can break this equation.
I'm just waiting for 2 different animations to render. 2 minutes per frame. Oh, that's great. That's great. That's good. It's good. It's good. How about, wait, maybe I should render them one by one. I know the whole parallelization bit, but maybe I should render them one by one, and this could actually speed them up a bit. Okay. The flow, so yeah, I'm just...
Down into ms divided by t, s divided by t. And we can group those two into E is equal to PV.
Pretty close.
Which means that our kinetic energy is just equal to velocity.
A guy. It's A guy. Just the last name. Guy is their last name. Tefta, that's just rude.
Which means that our velocity times momentum. Which means that our kinetic energy is just equal to momentum times velocity. And our kinetic energy is just equal to velocity PV. Which means that our kinetic energy is just equal to momentum times velocity.
Thank you, Mr. Tax. Turbo Tax! My favorite. Alright.
Now for electromagnetic radiation, it's a bit tricky, and that's because our velocity is...
This is actually not as much of editing as it seems, okay? No, I'm lying to myself. I'm just in denial. I'll just keep, yeah.
It's constant. It's the speed of light. So our equation becomes E equals PC. And because of some really difficult to understand relativity / quantum physics, which I just gave up on understanding on the stream and just left it for the wave map video, momentum of photons is just equal to this, where h is the Planck's constant.
The new
and lambda
color
is
theme
the wavelength
of Premiere though is so ugly.
So to recap, we took...
Like, it's not just me, is it? Look at these colors. Look at these colors. They're disgusting. The previous ones were so much nicer. Look at all of them. All of them are just label group. I can select. Oh no, never mind. That's not what I want to do. And that's just the newest Premiere. They did this. They did this knowing damn well what they're doing.
This equation from classical mechanics and this equation from relativistic quantum mechanics, and ended up with this equation for the energy of the photon. Next up, we'll have...
Oh, for this one we don't do 3D animations. How sweet. You're right, it doesn't look all that pleasing. Yeah, I mean, especially when you compare it to the previous ones. Hold on, I'm used to the previous ones, so let me just show you exactly what the previous ones look like. Unfortunately, I won't have to go far to show you, because I can just show you the last walking stream we did. Yeah. Look how much nicer this is. Look how much nicer this is in comparison to this. They did this. They switched them. This just looks like bath. Like that's the ugliest shade of green I've seen in a week. And I know my greens. I eat my greens and veggies to become big and strong.
For thermodynamics, it's really similar to...
Oh, why did I say for thermodynamics? I should have said for thermal energy. Because thermodynamics, that's, I mean, technically correct. I'm smoking my greens. Hey, you know, if you're just ingesting them greens, good for you.
It's really similar to kinetic energy, except this time it's more average. So how could we get that energy? Well, once again, for the fourth time, let's start with E equals ms squared divided by t squared. Now we can take this and reword it to say E is equal to fs.
This actually might genuinely not take me... Once again, I'm lying to myself, but this might not be as extreme. Okay, this segment will be a lot, because that's a lot of different animations. For this segment, however, this segment we're rendering right now, this segment will take like hour tops to render. Actually, for this we might have everything, because that's radiant, right? That would be just Manim. I think it might also just be Manim for thermal. Which means we might finish these two right now, and then just the ending.
So energy is equal to the force times the displacement. Now it's time for the ideal gas equation. Now it's time for the ideal gas law. Now it's time for the ideal gas law equation. So this
keeps pausing.
is equal to nkt, which states that the pressure.
Why am I editing like this? I should just do it with Manim, you know? And just add sound too. And then just make all the animations and then render them and then add them to the video and then finish the video, upload it to YouTube, get rich and famous by a bunch, you know, just live a happy life. I really should do that, shouldn't I? By the way, at the end of the stream, we'll finish the video. And the way I make videos, I make all of the videos, and then the last chapter is always the ad segment, and I always actually make it last, which is different from all the other chapters because, yeah, right here it just so happened that, you know, I finished the first chapters first, but like, for example, I finished this chapter, then the intro, then this one, now I'm working on this one, then this one. It's in random order, except for the last chapter, which is the ad segment. So for any of you troopers who actually managed to stay till the end of this live stream, if you all want to be in a video, yeah, I'll probably do it. I'll be really tired then, so my guard will be down. Go for it. Okay, hold on. We need Manim right now. And I know to find it because I did not, in fact, copy all of the Manim files. Instead, what, like, hey guy, would you like to be in the video? As in, you know, me? Would you like me to screenshot you in chat and put you in the video? As a reward for actually sticking here and actually somehow surviving this live stream. Projects Manim. There we go. That's the one. I would want nothing more. Hell yeah! But you'll have to stay. You'd have to stay to the end. That's not an easy task. Or just be at the end. You can leave and then join back, I suppose. Right, videos. Ah, fuck, where is it? Look at these file names. Jeez, they're awful. I don't know videos. That's the one. Okay. And right here, my entire file explorer is gonna glitch. And then we're gonna have the radiant energy. This.
You know what I said about the radiant energy?
Okay, so the last thing is S appearing. Okay. So this should be roughly the same frame. They're not. These are, however, the same frame. And because of how it's made... Oh wait, is that perfect already? Wow, that was quick. I did not expect this to work right away. I'm pretty certain this is the black... Yep, it is.
The wavelength? Why is that? Well, let's go back once again to kinetic energy and its equation. The wavelength? Why is that?
Well, there's actually video 1 explaining why, because the answer to why is relativistic quantum mechanics. And I don't want that. I still don't get it, but I guess I'll stick around sometimes, maybe. Yeah, fine.
Well, let's go back once again to kinetic energy and its equation.
I was trying to engage with the audience. That it's a thing them YouTubers do.
Of ms squared divided by t squared. Now we can break this equation down into ms divided by t, s divided by t, and we can s divided by t, and we can group those two into E. E is equal to PV, which means that our kinetic energy is just equal to momentum times velocity. Now for electromagnetic radiation, it's
Wait, why are we already there? Wait, what just happened? Go back. Maybe is where we are right now. There we go.
equal to momentum
Times velocity.
Now for electromagnetic radiation, it's a bit tricky, and that's because our velocity is constant. It's the speed of light. Sorry.
Do you prefer E is equal to H nu or E is equal to HF? I honestly don't like the fact that it's even a thing. The fact that like you have nu, you have F, you have all of these different values which are inverses of each other for absolutely no reason, and then H and H bar for once again no reason.
So our equation becomes
What's happened there? This label.
So our equation becomes E equals PC. And because of some really difficult...
Alright, let's make a tired make it. Shouldn't be that difficult. We've already been going 40 minutes. Oh, this is quick. This song is crazy. It really is. Fun fact, this song was made from Tefta's sample of the Make It theme. You can hear it right now. This is Tefta playing the Make It theme on the guitar. And then this is the AI's version of it. Okay. Oh wow, Golden Freddy. Pretty funny, okay. Hold on. New era, still working on. And now what we need is a tired make it. I'm not even gonna bother putting it into my actual file. How do we make a tired make it? I have an idea. We're just gonna have to make it dead on the floor. Defeated by the relativistic quantum mechanics of P is equal to H lambda. There we go. Dead! Maria, I want to say seeing you walk is really emotive for me, and yeah, thanks for that. Well, you're welcome, Mary, and good luck. I really hope I pronounced your name correctly, and good luck with whatever you're doing. I'm glad I can motivate you. Let's copy the camera. There we go. Just gonna have plenty of dead makers. Sleeping on the desk. I did want to do that originally. It's just that I will have to pop in the desk in there too. I feel like a bunch of defeated dead makers would be just as funny. Dead. What's the folder? Dead. PNG with alpha, pretty important. And also right here, make it easier for ourselves. PNG with alpha. There we go. Obsession with fire towers. What are fire towers? Never heard of a fire tower. Hold on, my taskbar broke. Again? That was quick. Well, it always is. It's a fire tower. Oh, this! You know what? I get why you'd be obsessed with that. That is actually... It does feel nice. It would feel nice, I feel like. Yeah, I think it would be nice. I mean, it's basically like living in a really, really high apartment. Except, first of all, you have a nice view, because it's a forest. Second of all, you have no neighbors, so that's convenient. And third of all, it's cool. I get the obsession. Would I smash or pass? I would... Well, wait, what were we doing? Oh yeah, right. Dead makers, that's right. So, collection 16. Let's copy the make it. The new collection. Sick. Now, move you right here. You will just be absolutely splattered on the floor. There we go. Another in a second, just first. There. Give me this. 180, and this make it will just be dead on the front. Another cool thing I could do, which would be pretty fun. How much do I care about this bit?
Really, really difficult to understand relativity slash quantity. And because of some...
Fine, let's do it. So what we're going to do is we're going to take the make-its, gonna render all of them at once, but we're also gonna add images plane, this, hot, and then that's transformation, this one. I'm gonna add this plane, I'm gonna take the camera, I'm gonna rotate the plane by the exact same amount as the camera. And then we're gonna take this, position it in the same spot, and then increase in size. Rip make it unpaid interns. I mean, we don't care about if they rest in peace, actually. All we care about is them not coming back, because that would actually slow the production down. We can't have that, can we? There we go. And that was just cool because we actually have the light from the floor. You know what? Let's boost it up a bit. This hand's going to the floor. Damn it! It's always something. There we go. And now it might be too low. It's not one thing, it's another. There. Let's take this hand up. Hey man, you should try more lightning. As in, you mean in videos in general, in this scene? You need to be a bit more specific. Your videos are too dark, are they? I mean, there are segments which are dark. This one feels bright. This one feels fairly bright. Is this too dark? No clue. Alright, right here for this bit.
The speed of light. So our equation.
Like the chemistry videos. Wait, videos, plural? The election one? You mean the election one? Do you mean the chemistry or which chemistry? As again, they are wildly different. Night dark, I'm watching 4 imaginary unions in the morning. I don't want to get flashback. I mean, yeah, I'm assuming that's when people watch my videos. Dead!
E equals PC. And because of some...
There.
really difficult to understand relativity slash quantum.
There, now we can cut each one out. Like this. Nope. This one.
Really difficult to understand relativity slash quantum physics, which I just gave up on understanding on the stream and just...
Oh, the acid bucket video. Oh yeah, that was actually meant to be dark. That one was the only, at least semi-artistic video on the channel. The entire idea of the acid video is like to show how, because most of my videos are about theory, and the entire idea of the acid bucket video was to show how in practice things don't always go as planned, and that's why it was dark actually. It was also progressively getting more and more dark as it went on.
Momentum of photons is my video. Then just left it for the wave map video. Momentum of photons is just equal to this, where H is the Planck's constant and lambda is the wavelength of photon.
That's convenient, I didn't even need to do anything. Oh. Sometimes the timing laws just bless me with outstanding timing and I don't have to walk a bit.
So to recap, we took this equation from
Oh wait, we have to recap.
classical mechanics, and this equation
Oh no, I didn't do a recap. Also, all of this is enlightened. That's... Is there any normal... Is there any difference? Not really, I'm leaving
this
it.
equation from classical mechanics,
Hey, Mega, how doing? Hi, the dragon, welcome.
and this equation from relativistic quantum.
No, we're not recapping because I didn't prepare any animations.
So to recap, we took this equation from classical mechanics,
We're not recapping.
and this equation from relativistic quantum mechanics, and ended up with this equation for the energy of the photon. Next up, we'll have
There we go. That's much better. Might as well leave it like this, actually.
for thermodynamics, it's thermodynamics. Next up, we'll have thermodynamics. It's
There we go. Maya, do you, maker of it, do you play Trackmania? Not, I do not. May prefer videos entirely on stream, do you prefer doing this stuff more on your own time? I don't, honestly, depends. There are certain videos which are really high in quality and I really do want to keep them off stream. Mainly because I like the element of surprise. I think it's really fun. There's one video which I'm currently working on, which I will not in any part make on stream specifically to keep it a secret, so that when I release it, everyone will be like, oh wow, I never saw it coming, you know, for that effect. But other times we'll probably make all of the average videos on stream. Make it, you work on multiple videos at once. Of course I do. I wouldn't be able to keep up if I was working one at a time. You seeing these render times? 1 frame a minute? If I was working one video at a time, I would just release one video a month. Because I'm working multiple ones. I would just like to mention that the acid video, I started working on that a month ago. And when it comes to this video, I started working on that 3 weeks ago. Well, actually 4 weeks at this point, I think. So, hold on, let me show you. When it goes to the video I'm currently, the big video I'm working on in the background, I started working on it right here. Then, right about this time, on stream, Flame taught me the sacred ways of electrons. So I made the electron video, because it was fun. And then this whole video was just a sped up version of this video, which is the one that actually took a month. All of that whilst working on the big video, and right here I started working on this video I'm making right now. So it's a lot, it's a lot. The process should be well, if you want to make it like the artistic look, it should get darker through this overlays darker. It's not supposed to be the dark kind of darker. It was supposed to be darker as in less lights to stop, as in just, you know. Yeah, there's an entire scene over there where I'm just boiling sulfuric acid. And I was specifically boiling sulfuric acid late in the day to capture, you know, the sun going down. As if it makes sense, you can't speed up chemical reactions or organize about the video. Precisely what I mean. Actually, that's what happens with all practical videos. Especially if you're electrolyzing a bucket. A bucket? That's a lot of solution, you know? Quite a lot.
For thermodynamics, it's really similar to kinetic energy, except this time.
Alright. This is electrical. Electrical would only have 2 magnets. That should be simple enough. I mean, we're getting there. It's like 5 more minutes, tops. I'm fine. and just a sip of coffee. And I'm ready. Take on the one. Alright. So let's start with the electrical energy, which is just kinetic energy with charge, basically.
So for electrical energy, we're going to start with this.
The last lessons were named 6 minutes. How hard can it be? No. Those 6 minutes ones were... no, in the 6 minute ones, I just wanted to finish 6 minutes. Right now, I want to finish all of it, which is from here... Hold on. This is 11 to 17, so this is 6.5. 6.5 plus... Actually, this wasn't finished when I started. So 6.5 plus 10. 16.5 minutes today. Hopefully. I mean, yes, how can I fucking just do it? Just make it up. We just need to make it up. And V is equal to Q. And that's... Right here we have the Q. This frame? Why the different frames? That's really odd. They should be the exact same. Apparently the frame rate of Blunder's higher than... I have no clue what's happening. How's the E already there? Alright. Once again we have to do that thing.
This.
Beautiful.
I won't re-explain how.
Yeah, I really want to explain how we got here because that's quite a story. How to get to this spot.
I won't re-explain how to get this equation here because that's the story.
It's a journey. Let me tell. Okay, I have like another video in which I explain how to get to this equation, and it's a journey. All right, I think it's 10 minutes long to get there, which is something. On the science channel? No. Another video I'm working for on the main channel. I'm working on a couple of videos. I'm mentally stable, thank you very much. In case anyone was wondering.
Because that's a story for another time and another video. So for now, you'll just have to trust me with this equation.
But fun fact, the first portion of that video, the one I'm referring to constantly, is on Patreon right now. It's as a preview. The first of, I think, 5 segments.
Equation which says that the velocity of our electrons is equal to the charge.
Oh, I don't indicate anything. And also this is... Okay, first thing I thought was broken, it's not. So I don't indicate anything, I just...
Equation which says that the velocity of our electrons
is equal to charge
multiplied by the magnitude of the electric field per mass times time. Okay, the point...
Alright, well, so I don't indicate anything, which is just great. That's cool. Thank you, Make It, for making me do all the work in editing. How sweet of you.
You just have to trust me with this equation. Equation which says that the velocity of our electrons is equal to the...
Where's that arrow? That arrow was made by Tefta, actually, funny enough. I still remember in my older videos I had a bit going. Well, not all the videos, just older videos. I had a bit going where basically at the end, when I was thanking everyone, instead of actually saying for what I'm thanking Tefta, I would just say like something along the lines of, yeah, Tefta, just thank you, there are too many things to list. And yeah, there really are too many things to list because they're just most random of BS. Like, Tefta made this. Oh yeah, Tefta made so many things for me. Out of the blue, this arrow was made by Tefta. This right here animation on stream was also made by Tefta. Tefta made me a theme. That's how it all started, actually. So whenever you see any 2D graphics, it's fair to assume it was just made by Tefta.
Charge multiplied by...
And that's why I use this arrow. Okay. We want it to be more this shade of red. Let's do 100, 100. Not to be exact 100, I suppose.
Multiplied by the magnitude of the electric field per mass per...
As we all know, mass is red, and anyone who says otherwise is just wrong and incorrect. So let's make mass red. Oh, is that it? We just burned through the entire my entire folder of music. Great. That sounds like a really nice guy. Hope to see him come into chat one day. Mass is black, temperature is red. Hey guy, I would really... if I were you, I would really thread carefully from now on, because you are one word away from a ban. I'm not gonna warn you again. Behave yourself. Just, like, I am fine with controversial opinions, but not just outright wrong ones. That's not a controversial opinion, that's just a lie. That's just a lie and heresy. Okay, green.
multiplied by the...
Well, I really like this arrow because it has all of the make it colors, and because of that you can just change it up with volumetry and actually give it different shades.
Per mass times time.
And
Okay,
fits.
the point is, if we divide both sides by...
And racism's good would be a correct opinion was. That's, you know, that's... What kind of... What? Where did you get the racism is good? Where did you get that from?
Okay, the point is, if we divide both sides by time, we'll get acceleration equal to this.
Sorry, that was the voices. Fair enough.
Acceleration equal to this. And if we multiply both sides equal to this. And if we multiply both sides by mass, we'll get by mass. Both sides by mass, we'll get force equal to this. I think you can see where this is going. Back in classical mechanics, we took the force acting...
Why did they indicate charge and... They indicate charge and magnetic field in the wrong spot? I did, didn't I?
Back in classical...
I did. I so very much did. Cool.
Force equal to this. I think you can see where this is going. Back in classical mechanics, we took the force acting upon an object, multiplied by distance, and got the...
Now we need to go back to 3D, which is a problem because I'm kind of in the middle of rendering something already. Oh, energy is yellow. Okay, that's correct, but you know you're on shaky ground, so I'll be careful about you. Claim that mass is black, like it's just silly, just dark. Hi, how are you doing? Hi, the Gregory. Hi, the superstar. I'm sorry, Gregory. Gregory. Oh, it's not Greg. You've caught me in a pretty bad shape. I hope your day is going well. You caught me in a pretty bad shape because I'm actually 5 minutes away from finishing a video. Just 5 minutes away, and so
where h is the Planck's constant and lambda is the wavelength of the photon. Next up, we'll have...
Alright, right here we'll have the thing switching. Good.
It gets hot, and the thermal energy really hot.
We should change the cross dissolve something better actually, because that's dumb. That's not how things heat up. How do things heat up? Wait, why did the player stop again? There we go. Now we're back. That's great. Can't wait to watch it. I can't wait to finish it. Honestly, I've been working on it for 4 weeks now. I think all of it on stream. Okay, no, because this is going straight to it. I'm pretty certain right here. I think there was either light rays. Was it? I think it was rays. No, that's absolutely not what I was looking for. Non-additive dissolve. This one. Is one the one that's getting brighter? Yes. Okay, kind of. That's not quite what I'm looking for. But what if I do this? And I crop top 50% with an edge feather like this. Why am I trying so hard? I don't know, couldn't tell you. I just wanted to shine, and then additive dissolve, and then cross dissolve. Okay. Entropy is purple. You know what? You're not wrong. You're not wrong. Entropy is purple. You're not wrong with this. Leaves are green. Oh, they're actually yellow. Okay. Is this good enough? Well, no, because it cuts off the edges. Really weird, like. So let's... Not you. I mean... Oh, I can't access the clip behind it. I just need to make myself an opening. There we go. So let's do left 24 and right 24. Now it's a perfect cube, which is also a problem. So let's delete the crop completely and let's instead do this.
Really scalding.
Good enough. That reminds you what all the color-rated controversial opinions I have. Hey guy, we don't like to be controversial here. Listen, I respect all opinions. Except for those who disagree with me, because they are wrong and evil. But you know, apart from those who disagree with me, I respect all opinions.
Imagine placing an engine on the bullet, which turns heat into...
This is kind of silly because I said engine, not generator. And in the animation is actually a light bulb attached to a generator, a thermoelectric one, so... Whoops. Looks like a stump, but... Okay. Each one takes a minute. What, if I turn off Premiere, will it go faster? Let's see. Last one was a minute long. What are your opinion on colors for binders for school? Binders? I don't know. I've never been. I'm not much of a school guy. I'm more of a YouTube guy. What's a binders? Science is green. Oh, you mean this? Yeah. Science isn't green, science is blue. If science is green, Gregory, listen, I like you, man. I like you. I really do. But just hold your horses, okay? Spreading misinformation, because science isn't green, science is blue. Okay, it might be teal sometimes. Sometimes it might be teal. But it's not... no. It's not green, you see. You see? No. It's not green. What's math then? Math is yellow. Everyone knows math is yellow. Hey guy, I know you misspelled it, but I really like how it reads. I feel like science has no color. Maybe gay color. Math is blue. You are not. No, you are all unreal. In what universe is math blue? You are unbelievable. It's yellow. It's yellow. I'm the math blue boat. Gregory, I'm sorry, but your boat is sinking. You're in the Titanic. You're gonna drown. You can't. You're in the wrong boat. As I mentioned, I respect all opinions, but you are just wrong. Math isn't blue. What? Come on, that's ridiculous. Science is blue. Science of teal, maybe. English is red. Yeah, that's true. English is red. Chairman is green! Okay, hey guy, you're embarrassing yourself. I did history in yellow. History is brown. History is grayish brown. That's what history is. History isn't yellow. Oh, come on. History is orange. Hey guy! Just, you're embarrassing yourself. Hey guy, you're absolutely embarrassing yourself. Polish is bright red. And I just only know the English. The English one. The English is red, that's obvious. What university is orange? It's grayish brown. Okay, it's not going any quicker, it's still a minute, so might as well go back from here. I had English orange because Sports is bright blue, almost cyan. Okay, yeah, fine, you're getting somewhere. Math is blue, you are ridiculous.
PC. And because of some...
Okay, this one will have to go back to 3D.
It's really simple.
Now only thermals left. What color is German then make it? It's yellowish orange. Of course it is. Dark yellowish orange. Is math purple? No, it's not purple. It's yellow. Ah, you're getting me upset. Oh, no politics! No politics on this live stream. For goodness sake. You're right, Jim is right. Of course I'm right! I'm always right! I'm absolutely always right. And you better remember that. Make it, is racism good or bad? That's what a tough question. That's a tough question. Alright, S this way, okay. Oh, this time the frames align. Oh, how sweet. How sweet.
Time it's more average. So how could we get that energy? Well,
This just cuts. Ah, damn it, of course it does. I forgot I'm the one who made the animation. Of course it's broken.
so how could we get that energy?
Is that the kinetic energy equations? Yes, it is. The entire topic of the video is energy. It's basically what is energy. And this is the conclusion chapter, where the conclusion is energy is just the concept, and thus, like, how should I put this? It's a very annoying thing to put. We divide energy into kinetic and potential, which isn't quite as great of a division because potential, first of all, is a misnomer, it's more static energy. But then kinetic energy is a concept, so depending on the model, it varies. So then you have kinetic energy in the classical model, but well, right here should be S squared. You have kinetic energy when accounting for charge, which basically leaves you with this, Q and E. You will have kinetic energy when talking about light, which requires different model because it has no mass. And then you have and because it's a wave particle, and then you have this one, which is kinetic energy when you're talking about the average velocity of a particle. That's kind of the point of the video. It depends on the model because it's a concept.
Except this time it's more average. So how could we get that energy? Well, once again, for the fourth time, let's start with E equals ms squared divided by t squared. Now we can take this and reward it to say E is equal to Fs.
Why did I reward it? There's no point to it, is there?
Squared divided by t squared.
Yeah,
now
there's no point in rewarding it.
And reward it to say E is equal to Fs. So energy is equal to the force times the displacement. Now it's time for the ideal gas law equation. So this PV is equal
Oh, that's a pretty good theme. I want new ones.
E equals ms squared divided by t squared. Now it's time for the ideal gas. Now it's time for the ideal gas law equation. So this.
Okay, so right here is where the ideal gas law should actually come.
Divided by t squared. Now it's time for the ideal gas law equation. So this.
My physics class never went in depth with any topic, just surface level and then never talk again. Potential energy got mentioned once and never again. Once? That's actually odd. It's really important. Potential energy is basically like when you have an object, when it depends on its position. That's most of the time what potential energy is, if not always. I'm not quite certain if it's always, so let's just say most of the time. So for example, you have based on gravity. If an object is really high in this case, then it has a lot of potential energy because gravity can cause it to do a lot of movement. When it comes to electrons, depending on where they are, they may have a lot of potential chemical energy, and so on and so forth. When is it not based on position? I can't remember any scenario in which it's not based on position. It's not just position, by the way, it's position in relation to something else. It can't just be positioned by itself. It needs to be positioned in relation to something else, and that something else then was the object to get energy.
So this PV is equal to NKT, which states that the pressure times volume is equal to the number of particles times the Boltzmann constant times absolute temperature. Now we're not.
Ooh, this timing was pretty sweet actually. I don't have to edit
Now
anything.
in order to,
That's rare.
in order to analyze why this equation could be useful to thermal energy, let's start with the right side. Amount of molecules, Boltzmann constant, and absolute temperature. In this case, we can just omit
The Boltzmann constant because we don't care about constants. Can you do a video of plasma physics? I've been trying to learn over summer, but it's messy. Plasma physics? That sounds really specific. I can do about different states of matter, but that would be a pretty short one. Because once again, it's just different models, same conclusion. Understand potential energy now, somewhat now. My physics class said nothing about it. Hey, listen, if you want to understand energy, I've got a whole video for you. Just give me like 5 more minutes tops, okay? Just 5 more minutes tops and I'll get it to you.
the Boltzmann constant because it's not really important. What is important is the N. Really important. What is important is the N times T because the absolute temperature. The absolute temperature basically tells us the average temperature
Hi, the telly. Hi. He said 5 minutes, 60 times. And I don't know why. Kinda just 5 minutes, all I need. I need just like 5 more minutes. And I'll probably go sleep before 5 minutes lasting 30 minutes go by. That's fair.
Basically tells us the average kinetic energy of a particle, and since n tells us the amount of molecules, and since the n tells us the amount of particles, and since energy of a particle, and since the n
I'm not pausing it, by the way. That's just Premiere pausing itself.
tells us the amount of particles, there. Now let's go back to our E is equal to ms squared. Now let's go back to our E equals. Now let's go back to our E is equal to ms. Now let's go back to our E equals m squared t squared and define another unit called a Pascal, which is just 4. Now let's go back to our E equals m squared t squared and define another unit called a Pascal, which is just force per area, which is just P is equal to m1 divided by t squared s.
That's a large
Now
gap.
we can see that if we take this pressure and multiply it by length, now we can see that if we take this pressure and multiply.
This sounds weird. Use it to make animations. Well, I use Blender for the 3D animations, Manim for the 2D animations. So this is made in Manim, this is made in Blender, and all the other animations I make either in Premiere or every now and then in After Effects when I'm feeling fancy. There's like a bunch of states of matter, like for example quark matter where there's a condition at 2 extremes from force to quark close. Yeah, there's a lot. There's a lot of different states of matter. And also another thing, the reason why plasma physics, there might be a lot of it, that's probably because it's basically thermodynamics, but more extreme. That's probably why. Like, there's a lot of physics when it comes to thermodynamics too, precisely for that reason.
And again by length, and again by length, we get this. So P s cubed is equal to m s squared divided by 6.
Oh, that's a sweet animation. I'm really proud of this one. That's a good one.
We get this.
Really nicely tying everything together.
So P s cubed is equal to m s squared divided by t squared. Or in other words, P s cubed is equal to the energy. P s cubed is equal.
Because S cubed is a volume. Thermodynamics plus charge plus fluid mechanics. Would there be fluid mechanics? Oh, maybe. Yeah, everything is complex depending on how
Energy.
exactly you want to be.
Length times length, and what is length cubed is equal to the energy. And what is length times length, and what is length times length times length, and what is length times length times length.
Actually, right here we might divide it a bit better.
That's a volume.
Oh, I have a good idea. Hold on. So what we're gonna do is we're gonna copy this, and then we're gonna keep this in. There we go. And then right here, what we're gonna do is we're also gonna copy this, add frame hold, set it as a background. Oh, I'm gonna really be cooking. And so there, and right here, we're gonna step this, envelop the entire movement of energy.
To the energy.
Okay, that's not what I meant. That's a bit.
And what is
Right here, we can delete the mask.
equal to the energy. And what is length times length times length? Well, that's a volume. And it is equal towards PS cubed is equal to the n to the
Why is it flashing all of a sudden? No, but that's wrong.
to the energy. And What is length?
Okay, so to the energy, so this middle we want it to be right there.
Or in other words, PS cubed is equal to the energy.
Ah, beautiful. If not for the fact that the mask isn't quite there. Should be better. Oh, actually we can cover this, I guess, yeah, as well.
PS cubed is
In the right here we can cut this again. Delete the mask.
cubed is equal to the energy. And what is length times length times length? Well, that's a volume.
Then right here we're gonna do. Gonna take this mask. We're gonna paste it right here.
And what is length times length times length? Well, that's a
And this will have the same exact mask except inverted.
volume.
Inverted, I said.
A volume, which means a volume.
Ah, but earlier on.
A volume.
And then there we
Which
go.
means-
Right here we can delete the mask.
Which means PV is equal to E. And if we merge it with the ideal gas law equation, there. So that's the kinetic energy. So that's the
Yeah, it's not really kinetic, is it?
So that's the kinetic energy.
There we go. What's capital T? Temperature? Yes, it's absolute temperature. So basically, average velocity of a molecule. Or actually, average velocity, how much momentum of a molecule. Hey, you promised a video on waves, I could use one right now. I've been promising a video on waves for months now. So, don't get your hopes up.
So that's the thermal energy. Well, one of them at least. And right here we can already see a certain pattern develop. You see, pattern develop. You see,
There we go. Oh my goodness. That's the big chunk. Oh, I have exams soon. Yeah. What are you doing with the waves? You see, I've been talking a lot about quantum mechanics regularly, and I just wanted to make like a waves video which would explain all the maths. And I mean all the maths required for quantum mechanics. In depth, extremely in depth. But that video will take a lot of effort, and honestly, I kind of wanted to do it with the other math YouTubers. A little bit, just a little bit, you know. Kind of want to do it. Okay. Alright. That's a tall order. Yeah, I know. Yeah, Megan, I could really use a video right now explaining all of physics, chemistry, biology, mathematics, and history, please. Coming right up. Hey, interns. We got a video order. Just give me like 7 to 8 years. Yeah, I'll be right there. Okay, so these are done. That's neat. How's the render? Still not done. Oh, how swell. Good, good. It's good. It's fine. It's only half an hour more. Okay, well, I feel like right about now would be a time to... Hold on, my taskbar is broken. Yet again. No, at the end of the day. No, I meant to turn off. That's what I meant to turn off. There we go. Fixed it right up. So. Right now, I feel like let's go by. Bye and Gregory, bye. Have a good one. Right now, what we could do is set up all the animation, I guess, in the meantime, while this is rendering. The reason why it's rendering such a long time is because of this volume is here. Never mind, I thought you were in the stream. Oh no, absolutely not. I'm gonna finish this video. I'm gonna finish this sucker. I'm not giving up. Well, I might later, but leaving that window open for myself. No, Oscar, just 5 more minutes. Precisely. Why would I end now? I only need like 5 more minutes. Come on. Okay. Okay. So, ideally, if I could finish... Okay, I need to focus on this. If I finish this segment, we're doing great. The problem is this segment also has a volume, which unfortunately means it also will take a fair bit to render. Okay, let's look for something else we can edit in the meantime whilst these two animations are rendering. Yeah, you can see the volume right here, these pixels, that's the volume. And I want to keep it in because it gives them this nice glow. Ooh. I hate English language with silly spelling. All of it has silly spelling. Alright, let's look for something we could hopefully finish right here.
Which turns heat into electricity. Now after placing this engine we get electricity and we can use it to do work. In this case I don't mean the human abstract kind of work, I mean the physical unit of work. Now what's really interesting is that for thermal energy, when we use it in engines, we don't really actually care about how hot something is, only about how hot it is in relation to other things, like the engine for example. Now why is that important? Well, it's because if we go back to the ball and give it a velocity of 5 meters per second to the right, then congrats, it has...
And this segment, I really don't like this example.
Well, it's because if we go back to the ball
Let's see if I
and
can
give
cut
it a
this.
velocity of 5 meters per second to the
Make
right,
it this
then
hot in relation to
congrats,
everything,
it has
hell yeah.
kinetic energy. But if we give everything velocity of 5 meters to the right, then it still has the energy, but so does everything else. And now there is no work that can be done with that
Yeah,
energy.
this example sucks.
That's entropy. So basically just useless energy, energy which has no effect, energy which due to its circumstances just can't achieve any work. We really often like to think of entropy as mixing stuff together, and there is a reason.
But this also is kind of integral. Huh? Let me just check out to see entropy, to make sure that this example is sound, because I don't trust it. Measure of amount of thermal energy never will do work. Yes, thermal. Precisely the problem. Yeah, that's why this example sucks so much.
Now why is that important? Well, it's because if we go back to think of entropy as mixing stuff together, and there is a reason for it. It's because when you mix stuff together, it takes less...
Hi there, Alex! Oh my goodness, speak of the physics and Alex shall appear. Hi Alex, hi, welcome, hi.
energy to mix stuff than it takes to pull them apart. But the energy stays constant, which means that it takes less useful energy to mix than to pull them apart. And whilst energy is the theoretical measure of work you can do, entropy tells you the difference between the practical amount of work you can do and the theoretical one. So going back to our thermoelectric generator for a second, so the generator which turns thermal energy into electrical energy, there is a problem. Because you see, this
Alex, did you learn string theory? No, that was my job. I was meant to learn string theory, and I still will. I just need to finish this video, which shouldn't be that hard. We just need like 5 more minutes, and then we'll be done. So 5 more minutes, I finish this video, and then we can go straight for learning. Well, we won't learn string theory. We have to do it in order. First, we're gonna probably do relativity. That sounds wrong. That sounds like as if I'm gonna actually learn, all of relativity. I'm gonna attach string theory with a 5-foot string. That is fair. I mean, string theory only works in like a 9 dimension, doesn't it? That's such a shady term. I don't trust it. I think what it actually means is that you need 9 numbers describing position. That's literally what it means, I think. And if that is actually what it means, that I just really want to debunk string theory. That's my own personal goal, personal vendetta against dimensions. One is 10 dimensions, other 11, the bosonic string theory is 26. Cool! All of them have different numbers, like how lovely. I'm actually curious as to why it needs so many. Oh well. Iteration of string theory, which all more requirements and up to 13 in one time now. Huh! The thing with string is that it uses one more dimension three. I just don't trust these dimensions. That's why I want to check it, because I don't trust these dimensions. Hold on.
Things, like the engine, for example. Now, why is that important? For example. Now, why is that important?
Because of entropy.
Because of...
How lovely. There we go. What's the audio gain on this bad boy? 7.3. Alright.
Because... Why is that important? Because of entropy.
And I'll just take all of these and just pop them right in here. There we go.
I really often like to think of entropy as mixing stuff together, and...
Do you like string theory? Why are we asking Alex? I'm the guy who's supposed to do it. Alex don't care for no silly strings. Someone said the Trump, it's funny. Not remake area. Wait, Alex, actually, you know what? That's a good question. What is your area? Because so far, I remember you helping me with quantum mechanics, electricity, if I'm not mistaken, classical mechanics, and you tied something to astromechanics. Also, you nudged me with relativity. What is your area exactly? I have no clue why string theory needs all those dimensions. I do think it's just mathematics though. Of course it's all mathematics. What else is it gonna be? Nano optics and plasmonics, obviously. I see. Yeah, I should have figured it out. Nano optics. Wait, nano optics? What is that? I mean, I get what nano, I get what optics means. What the hell is either of those? Well, nano-optics is relatively self-explanatory. Plasmonics, that sounds... What is that? Hold on. That sounds like something you... That sounds like something lethal you'd get in a hospital, honestly. Monics. Nano-optics is just optics for nanoscale. Well, yeah, I figured. Relatively self-explanatory. Generation detection manipulated signals of the configured metal nanometer scans where photonics was one. Well, that's the question though, because nano, I think electron microscopes are on the pico scale, if I ain't mistaken, unless I am mistaken. You get way of assuming life field depth such a large ligand that is constant, but still so large the material is not really made of single atoms. I see. I actually have the scale relatively memorized now because I've been doing so much chemistry without using them all. Instead I've been just using yoctograms. Okay. How long is it gonna take? No, 2 minutes now. Go, yeah, because I turned on the other animation. Oh, but now it takes 2:43, which means 3 isn't worth it, is it? That's great. In plasma is about plasma, there are bundles of electric field that form at the surface of metals. Jeez. How come you've never mentioned this stuff? It feels like such a natural thing to come up in conversation. What about the cult second? Well, no, I'm gonna have difference in... I don't know. My girl was actually co-working with the chemistry department to use to simulate reactions. That is really cool. That is actually... Wow. Wow. You know what? I'm insulted that you've never mentioned this before. That's beating a little too. Hell yeah! Oh my goodness. Now I know that there are at least 2 people on the Discord server who are actual researchers, which I find really cool. Actually, you know what? Hold on. You give me. You know what? I don't know if you meant to do it by saying bleeding edge research, but you actually gave me an idea. Alex, would you like to walk with me on like a 4-minute long segment of a video? I'm not. By the way, I'm not putting pressure on it, I'm just waiting for this to render in the background. Hello everyone, welcome to yet another entertaining Make It live stream in which I'm sitting and waiting for animation to render. Well, I'm currently in the process of writing my thesis, and my schedule is pretty tight, but you have mine. Do not worry about it, it's fine. Remember the video about the increasing complexity, increasing the difficulty and complexity in physics, where I wanted to start with classical mechanics, then move on to quantum, quantum relativistic, string theory, bleeding edge. Well, as I already mentioned, originally I was going to do like the entire idea of the video was going to be this bit where progressively as I go on, I understand less and less, and I get to bleeding edge and I understand absolutely nothing. And then the conclusion of the video is that equations don't have to look more difficult than they actually... That doesn't matter. The point is, it would be pretty cool if you'd like to walk me on the bleeding edge segment. It would be pretty cool to like walk with an actual researcher to make a segment about their actual research. I'm just it would be pretty cool. But do feel free to say no, because I do understand having a schedule which is pretty tight. Trust me, I do. The edge B, will you edge the viewers? Hey guy, I will give you some time to reflect on the comment you just left. Just think about it, just like really think about how your message was received, how it was meant to be received. Think about the purpose, like why did you write that message and was it actually worth it? No, don't say my bad, no. Actually, I want you to actually understand what you look like right now after having sent that message. What do we do? No, I don't want to insult you. I just want you to realize the looks of it, okay? People really often complain about brain rot, but I just want you to actually look at that message right now in silence and think about what you've done. Well, I'm gonna sit right there before you assume more about me is true. I'm not currently engaged in any actual research, but I'm more or less in the work group of my supervisor. I'm a master student. Alex! Oh my goodness, why does it always happen with y'all? That's how research... Why do... This is the second time I'm actually going through this. If you're working on the research, as in you're, you know, as you put it, more or less in the work group of my supervisor, I'm a master's... Okay, if you are in the work group of your supervisor, but you are working on some actual new research, then yes, I still consider you a researcher who's working on some new research. I've already been over this with Flame. I know that there is like... I'm listening to presentations and stuff. Like, would you have to understand the distinction? I know that there is, for most cases at least, I know that there is this one person who starts the whole thing, who's like, I don't know, a PhD doctorate professor who's won 3 Nobel Prizes and ... at the end. I know there's always this one person who's starting the whole thing. At least that's the description I had most of the time. Just always this legendary figure who's actually in charge of the project. But I don't consider only them to be researchers. They would be the main ones. If we only define researchers as those, you know, who actually start the project, only take the most core central part, then we will have only a handful of researchers on the planet. And also, you've helped me with a lot of videos, so that's also, I'm also using that information, and, you know, you do know a lot. That heat is the ash of energy. Temperature is just the measure of it, no? I originally... Go and polish my ego. Not my fault you all have an inferiority complex. So, Ashad originally, funny enough, originally this was supposed to be heat. And I'm pretty certain, in the script, it might still be heat. Hold on, let me check. Heat as the ash of energy. In the script, it was heat, but I specifically changed it to temperature because temperature is the measure, heat is the transfer. So you can actually use heat. Heat is more useful than temperature. Heat is energy. Yeah. Heat is more useful in this case. So, right, this is actually a great example because it's specifically for that. This is supposed to represent a thermoelectric generator, and the way thermoelectric generator works is it works with a difference of temperatures. So if this is really hot, this is cold, it will generate electricity. But if both this right here and this right here is really hot, then you have a lot of temperature, but no useful energy. And that's because, well, temperature is the ash of energy. It's only useful when there's a difference. Because when there isn't a difference, you just have molecules moving in all sorts of ways and directions, and there's nothing useful in there. Ali, hi, welcome, how you doing? Oh my goodness, we're getting all of them, all of the blue names this live stream. Hi Ali, I'm almost done with the video, it's like 5 more minutes, that's all I need, it's like 5 minutes tops. Oh boy. It's like 5 more minutes. I had a hemiplegic migraine this morning, but I'm good now. Oh, is that how bad it is? It as bad as it sounds? Just 5 more minutes. No, it's just 5 more minutes. That's 5 minutes. Oh, I can chop it. Like a migraine on acid, it's not fun. Are those just... okay, does it just appear out of nowhere, or is there like a cause for it? How worried should I be? Nothing to worry about, I get them frequently. Oh yeah, it's... You have a pretty... okay. You actually remind me of my friend a lot right now. I have this one friend who's really awful at using the "oh yeah, it's fine" tone in normal conversation. where they basically use the tone of, oh yeah, you shouldn't worry about that, it's fine, but they also at the same time say the exact opposites. For example, nothing to worry about. I get them frequently is... That's... That's not better, is it? Hey, so I coughed up blood yesterday. Oh no, that's awful. Oh, don't worry, I've been coughing up blood for months now. It's not scary. Okay, I trust you, because you would know. Right? But I trust you. Good, good. I'm looking. 179. What Donald Trump could on Sunday day one? Yeah, yeah. Terrifying. People are memeing about this without realizing that it was an attempt at a probably one of the most major political assassinations of all time. White humorist. But no, but I don't really like that sort of sentiment. You do have a lot of people who are pissed at Trump and they are like, oh, why did you... That's horrible. Y'all are wishing it death. That's murder. Distracted by water. Trump was confirming as player. That was the balls on this man though. Fucking hell. Getting shot and then... In the ear, by the way. In the ear. No one deserves to be assassinated, precisely. But like, getting shot in the ear is the most terrifying way to get shot possible. And that's because getting shot in the head is the most deadly. And getting shot in the ear is the closest you can get to the head without dying. So, he got shot in the ear, and the motherfucker just stood up with fist in the air. That's the balls on this man. I just wish it wasn't like staged or something. That would be awful. I'm wishing for anyway for him to not run for president. Honestly, after that, show business intrigue. Sadly, what do you mean show business? I'd do it. I don't think it was staged. Yeah, it. I'm probably paranoid, you're right. But like, oh my goodness, can you imagine? Show business instinct, sadly though, that's... For some reason that hurts me, I don't know why, I feel offended. Listen, if I got shot in the ear, and like, I had a whole group of security guys around me, you better believe. Because who would put themselves in that kind of danger? I would like to invoke my right to not comment on the matter. No, but then, oh my, just that, you gotta respect that, honestly. Remember what happened when there was an election? I mean, oh, you mean January, the January. Let's call it horseplay. Yeah, but don't worry, Alex. Alex, if there's hold on, let me find it. Don't worry, Alex. He won't lose this time. How many 5 minutes is it gonna take? It's just 5 more minutes, that's it. What do you mean how many 5 minutes? Just one 5 more minutes. That's all we need to win. There. That's a pretty massive difference. Capital Office, size. Me when I'm asking when it's done. It's always 5 more minutes. It is 5 more minutes! Ooh, I could do a really solid sexism joke, but I won't. Because I'm above that. We don't need low-hanging fruits yet. Try checkups, we're professionals. Yep, and right when I said it, every single person watching the stream without the blue name, I said totally do it. I mean, it's a good joke, you know, but it has to be funny. No, it's not funny. It's just low-hanging fruit. You know, these low-hanging fruits. Mic drop. Hell yeah. "16 more minutes and then the animation is done. But just 5 more minutes and I finish the video." So, how are your political assassinations going now? But isn't it crazy? That was a genuine, like, extremely major attempt at a political assassination. Could you imagine what would happen if they should have succeeded? I mean, that's insane. Hold on, setup, is that the one? That would be just chaos. It's terrible, it's horrible. If you die and 2 others got injured. Oh, I didn't even get to that part. Trump. Okay, we need to wait for this to run up. It's awful. It's worse than awful. It's way worse than awful. My sulfuric acid video is awful. This is way beyond awful. That image from below though gets me a bit teared up. Patriotism. Hold on. Which image? Oh, for a second I thought both of my taskbars were broken. No, only one. Oh yeah, how did you all like... Hold on, let me find it. How did you like the most recent Make It verse? Oh, it's such a good looking image. So real, Alex was in the chat. Yeah, I mean that... the Trump one... The balls on this man, that's all I can say. Stars and stripes with me. You can't see me, but I'm saluting right now. I'm really happy with this though. The most I mean Oscar trophy this week. Yeah, I am, and I'm holding a little Oscar. Look at this. I'm an Oscar trophy that's holding a little Oscar. Make it little right there. Hold on, let me just. There we go. There. That's an Oscar make it, holding an Oscar make it. It's a bit too small, I know. Oh, I've had a nickel for every single time. I heard that. Am I right? I meant another one. Another one? Hold on. 2. No, that's Ali shaming me for being a gooner. Where's the other one? The one with the flag. Oh, I know which one you mean. Okay. Come on, find it. Yes. Oh, yes. Yes. I mean... at this point, like... you couldn't stage it to be better. Like, even if they did it on a separate photo shoot, it wouldn't just... That's just... I mean, it's perfect. It was meant to be. This one will go down as the image of Trump as president. Yeah, national anthem plays. Like, you can feel the ego screech in this one. Just wow. I think I just Trump shot the first photo, precisely. But that's enough politics for now. I think. I don't know, we might come back to it, probably. We probably will. I don't actually have an idea for a segue to another conversation. So we might stay with this one. Still waiting for this, just 10 more minutes though. And then it's done. How lovely. I'll go now, bye bye. Bye, hey guy, bye and have a good one. Anything else that happened, by the way, while I was away, not streaming? Boy, I miss out on the good stuff. Happens. Well, I guess, you know, a podcast assassination is not good stuff. I guess not. Oops. So, anyone watches The Boys, maybe? Ah, my eyes hurt when I look around. I do. Oh, you do? Oh my goodness! Oh, everyone keeps saying no! Oh, wow, you're one first person that actually says, what? How do you like the fourth season? Season 4 is wild, honestly. It is! It really is! Oh my goodness, wait, when does the final episode come out? Hold on. The Boys Season 4 Episode 8. Oh, did it already come out and I missed it? Oh, please don't tell me I missed it. Preview, release date, release date, 18th. Oh, it's in 4 days. Oh. Season 4 is wild. I don't really understand what's happening with Homelander though, because Homelander in season 4 is jumping around with character development so much. Like episode 1 through 3, it was just awful. Episode 4, all of a sudden, he went through a character arc, somehow. So big of an idiot, to be fair. But that's what's so wild to me. Like, Homelander oscillates between being the biggest idiot in existence and like the smartest person on the planet. Oscillates. He's meeting with Sage. That was genius. His treatment of Sage, that was idiotic. His willingness to actually go along with the plan, genius. Him then ending up doing into the plan what he did to the plan, idiotic. Just oscillates back and forth. Exactly, I don't like it at all. I honestly, I don't know if I like. I just don't understand it, honestly. The way Homelander treats Ryan is just, once again, 50-50. Either the best dad on the planet or the worst dad. There's no in between. Like, so confusing. Everyone agrees Kimiko is the best. That's obvious. Frenchie, oh my goodness. Just low-key being the best scientist on the planet. Just casually. That's the job I want to have when I grow up. When I'll be all big and, you know, strong. When I grow up, that's the job I want to have. Frenchie can fuck off. Frenchie can fuck right off this season, honestly. I don't know. Well, okay, Frenchie is pretty insignificant, to be fair. I don't know. Well, is he? Have you seen episode 7, Alex? The whole thing with the police was so unnecessary. Yes, it was. But like, I would say episode 8, Frenchie might be kind of significant. A-Train had splendid character development. I love it. Deep just... Well, deep in, I suppose. Butcher, I mean, obviously. Butcher, mwah. Perfect. The reveal in episode, I think it was, wait, was it 6 or was it 5? I think it might have been 6. I don't want to spoil too much. I'm trying my best to not spoil to anyone else. 6, yes, yeah, you know what? That reveal, I mean, outstanding. That was amazing. So good. That was, oh. I am curious though how quickly are they gonna, it's like, because fourth season last season? It feels kind of like it. The Boys final season. It feels like they've set a lot, and I mean a lot of deadlines on themselves with the way that plot is developing. But it also feels like they don't have enough time to actually tie in, you know, all the loose ends. So I'm really curious to see where this will go. People are speculating that a certain person in fact will not die. Well, yeah, I mean, obviously not. Oh, I'm not saying that, I'm not talking about that. I'm not talking about that certain person not dying, because obviously they can't die. I mean, come on. What I'm saying is more like about the political environment in The Boys. You know, they keep upping the steam. They keep adding more oil to the fire, adding more gasoline. It has to implode at some point. Like, at this point, The Boys is weeks away from, like, a civil war. But this whole thing has to be resolved before it ends, right? I mean... I just want to see Butcher absolutely fucking bash Homelander's face in. And I feel like, you know what, and I think that's a pretty normal thing to say. I feel like everyone does. Everyone just wants to see Butch absolutely, you know, bash it to Edson. It's done. Almost 3 more frames. Just 3 more minutes. Oh. Oh, I'm sorry, I just blacked out for a second. Hypnotized by this cube. Right, am I really going to finish the video today? I mean, I know I keep saying it, but... I might need to optimize the scenes that will come later to speed up the renders a bit. I'm back, my followers. Good pizza, so I get snagged. It's nice of bizarre. Oh, I do have a bit of an like an inkling for pizza. You know, I might order some tomorrow, maybe on 2 days, or maybe I'm just hungry. I prefer veggie pizza, but wait, you mean vegetarian or pizza with vegetables? Because those are two completely different. Actually, no, vegetarian or vegan. Also, another important. Vegan, vegetarian, or just veggie? Incredibly important distinction. Vegetarian. Really? I don't know, some meat would be nice. Wait, that would be margarita, yeah, right? Is that what it's called? No. Oh no, that's a drink. What's it called? I could never be vegan, that's so difficult. Yeah, they just... They can't eat cheese. This is my favorite one. This one. Oh, it's so good. It's so good. I mean, look at that. Look at that thing. Damn, I'm hungry. Hold on. Let me just... a reminder for myself next time in the shops to buy some frozen pizza. It's finished. Yay. Now we can run this. There we go. And in the meantime, walk on this segment.
Then imagine placing an engine on top of it, which turns heat into electricity. Now after placing...
That looks pretty nice.
Then imagine placing an engine on top of it, which turns heat into electricity. Now after placing this engine...
I'm not pausing it, by the way. That's just Premiere being broken.
Now,
I don't like
engine,
olives. That's fair. I love olives, but I get why people don't like them.
placing this engine, we get electricity, and we can use it to do work. In this case, I don't mean the human abstract kind of work. I mean the physical unit of work. Now, what's really interesting is that for thermal energy, when we use it in engines, we don't really actually care about how hot something is, only about how hot it is in relation to other things, like the engine, for example. Now, why is that? We don't really actually...
Let me get my arrow. How did they even make it? Just edit. Hold on, having a stroke. I've been working on the video. That's how it's been. I'm really in need of a Lethal Company live stream after this. Or maybe I should edit the clip back out because I recorded that live stream too to get in high quality. I kind of want to make a video of it. I'm trying to upload to other other channels from now on. That's why, for example, why this channel got so many videos recently. I have the hardest hitting image, which this image is so, God. That's like the hardest image on the planet, at least.
Only about how.
Once again, I'm not pausing it. That's just Premiere being Premiere.
Hot it is in relation to other things.
Nope, that's wrong one. There we go. And we care about how this in relation to the generator. There we go. But in this video, it's going to take up. You know what? Good question actually. Let's see. Let's see how much it takes up already. It's taking up 21. That's not a lot. That's not a lot at all. That's 21 gigabytes. In comparison, the sulfuric bucket video right now is taking up 300 gigabytes. Oh boy, I should really get rid of it. That's a lot of gigabytes.
Like the engine, for example. Now, why is that important? Because of entropy. We really often like to think of entropy as mixing stuff together, and there is a reason for it. It's because
it's crazy. It is. Even for my standard, it is crazy. That might be one of the biggest videos, mostly because of hours, literal hours of time lapses. I might need to make myself another coffee. I'm running out of this one.
We often like to think of entropy as mixing stuff together, and there is a reason for it. It's because when you mix stuff together, it takes less energy to mix stuff than...
This is just gonna be a solid frame. I have no idea what to animate for this.
Stays constant, which means that it takes less useful energy to mix than to pull them apart. And whilst energy is the theoretical measure of work you can do, entropy tells you the difference between the practical amount of work you can do and the theoretical one. So going... And whilst energy is the theoretical measure of work you can do, entropy tells you the difference between the...
Energy tells you how much work you can do. There we go. This one, I don't really know exactly what to Coffee indeed.
Entropy. We really often like to think of entropy as mixing stuff together, and there is a reason for it. It's cool energy to mix, then to pull them apart. And whilst energy...
Oh yeah, I forgot, you can't do animations on freeze frames for some reason. Because Premiere is just different.
And whilst energy is the...
There we go. Oh, we're slowly getting there.
theoretical...
Just 5 more minutes. That's all I need. Just 5 more minutes. It's not that much, is it?
Work you can do, entropy tells you the difference between the practical amount of work you can do and the theoretical one.
Energy tells you how much we can do, and then let's color this yellow because it's gonna look a bit nicer. There we go. Let's color this purple. Not this purple. There we go. This purple. It's gonna be entropy. Tells you. No, we're gonna be Disney World 5 minutes on it. Yeah, just 5 minutes of video. How long till the video starts? How much work you can't do because of the because thermal energy is the average movement of particles. In this case, I don't like this because this is pretty awful actually video making. Just putting a bunch of text on screen. That's not how you're supposed to make videos. Where did you go? That's where you went, okay. So normally I should avoid these segments of text on screen. But I have a question. Go right ahead. I was stalling. I have nothing interesting to say.
The practical one you can do and the theoretical one. So going back to our thermoelectric generator for a second. So the generator which turns thermal energy into electrical energy, there is a problem because so going back to our thermoelectric generator for a second. So the generator which turns thermal energy into electrical energy.
Do you think in Polish or English? Because when I speak Spanish, I still think English, but you're fluent in both. I think in English.
So going...
I have dreams in English too. What's your mind palace language? I find English more expressive. It's easier for me to find specific words. My favorite example is like basically saying that I have an English vocabulary and I don't know what vocabulary is in Polish. I don't know if there is a word for it in Polish. That's crazy. I don't know. It's actually pretty common for most like bilingual people I know. I have to realize that there is like English is more useful because a lot more people speak English than Polish, right? So
back to our thermoelectric generator for a second. So the generator which turns thermal energy into electrical energy, there is a problem because you see this generator doesn't really need thermal energy. What it needs is a difference in temperature, so a difference in thermal energies.
I know English is one of the large languages. Definitely not the largest, pretty big. What do you mean definitely not the largest? I mean, it may be not the largest, but definitely? I would say it might be the largest, actually. How many people do you know in America who speak Indian? Hindu? I have no clue. I'm not a geography person. I'm saying dictionary-wise. Oh, you mean like when it comes to wars? Oh no, then it's not large. It's not large at all. Actually, it's pretty small. I know like 5. Yeah, then my point is irrelevant actually. The thing about English, which is pretty nice, is that it's a universal language. It's practically the only universal language we have. Listen, the Brits are awful. Listen, I hate the Brits as much as the next person. Okay, but at least everyone speaks English now, so that's kind of convenient. Can you imagine what a mess the world would be if we wouldn't have the English language? If we wouldn't have like an actual universal language, that would be.
Is that if our generator was just as hot as the cube it sits on, it would generate no electrical energy.
Okay, this one, yeah. Now let's save as a new one. This, and then this parent to this one, there we go. Delete all keyframes. I said all keyframes. Move this -3 meters to the left. Copy, move this 6 meters to the right. And then what we're gonna do is we're gonna right here, we're gonna have this also set to hot. And because of that, this right here will need this, and this will need to be 0. This will need to be unwrapped. That doesn't seem too unwrapped, does it? Much better. And then we're gonna have this cube 1 meter up, make it smaller. Do it right here, -3. Then the background. -4. There we go. And then -1. And then what we'll have is this one will be the thermal energy measure. So 1 and dark orangish, and this one will be the entropy measure. So 1 and purplish. No. This, there we go. Then we're gonna have both of them scaled up. That's enough. And this one even higher. Add text. I really don't appreciate just how quick I am with this actually. For me it's natural because I'm a loser with no life who spends all the time in Blender, but nah, it looks awful. That looks really bad. Let's just put entropy right here and thermal energy right there. The dumbest possible placement I can think of, but oh well. And entropy thermal energy like this. Hold on, show me the thing. Copy it. 14. No. 16. No. 15. There, and this one will have higher thermal energy too. And the entire idea here is, it doesn't really matter if you have a lot of thermal energy. We might actually need a third bar. If we move this one to the right, it's gonna be a bit obscured, but oh well. minutes, which would be useful energy. Alex, as as physics person, people, human being, do you approve of my graphic? Okay, dinner. I'll be back in 5 minutes. Alright. I'll actually finish the video in 5 minutes, so we know. You better be quick. How long has been the corner make it so large? Well, there we go. Be smaller, my guy. I don't need you to be this massive. Absolutely. Okay, I'm really glad to hear because I really didn't feel like we're making. Nah, I'm kidding. I would. Wasn't accurate enough. There. Actually, this should speak for itself. You could have modeled the thermodynamic generator solo with effort. You're right. I actually could have I could have actually built a thermoelectric generator, you know? Why use Blender when you could just build it in real life? And then actually use it and show it in the video and, you know, as an actual practical experiment. Let's see, does this fit, by the way?
So going back to our thermoelectric generator for a second, so the generator which turns thermal energy into electrical energy, there is a problem. Because you see, this generator doesn't really need thermal energy. What it needs is a difference in temperature, so a difference in thermal energies. Which means that if our generator was just as hot as the cube it sits on, it would generate no electricity.
Alright, I feel like these three are good enough. Why do I feel the need to put in the volume every single time? That's hours of render time in the end. Days, possibly, actually. It actually might not even be an overestimate. Where can I find the make theme? The theme 3, you mean? Do you mean the theme 3 or do you mean the AI generated one? Because for the AI generated one, nowhere, it's not public anywhere, but if you mean the theme 3, then on Soda KC Music on YouTube, hold on. This one. A remix of one of Makeit's old songs for his channel. Funny enough, actually not the AI one. Oh, then that's perfect because that's the only one that's actually on YouTube. There you have it. Looking through hundreds of his songs. Yeah, the official name of the song is The Theme 3, by the way. That's the official name. It's The Theme. Hold on. 40, 41, 42. There we go. And then the other render, which will be this with the other generator. Okay. Wait, we've been at this for 2.5 hours already. It feels like half an hour. Time is passing by when you're having fun and editing a video we've been working on for 4 weeks. Five minutes. I mean, that's all I need, you know, honestly. I don't want to. All I need is 5 minutes. That's all I need. 5 minutes. You know what? You are right. We haven't been working on this for 2.5 hours because there's only 5 minutes left. All I need is like 5 more minutes tops. 5 more minutes tops, and it will be finished. That's, you know what? That's all I need. 5 more minutes tops, and the video will be over. We'll be done. It will be great. It'll be great, fantastic, amazing, lovely. Another quick sip of coffee. Get me going through these next 5 minutes. I'm gonna finish the video, and there won't be any problems. The cope has been ingrained in your being. What do you mean the cope? I'm just stating facts. It will just take me 5 minutes tops. That's all I need. Real, yeah, this post was fact-checked by real American patriots. Oh no, American Make It in the corner is gone. I keep forgetting we now have an Oscar Make It. Alright. 2 minutes per frame. Welcome to my world now. I've got friends on the other side. This one and one more. Just one more quick render like this. There we go. Only 2.5 frames. Precisely. Well, I need anything else. Okay, this I think. There we go.
Theoretical one. So going back to our thermoelectric generator for a second, so the generator which turns thermal energy into electrical energy, there is a problem. Because you see...
How often do you let it run when you sleep? I try... You mean my computer or do you mean Blender? Because when it comes to Blender, I try always. If I'm going to sleep without something rendering in the background, I feel bad because I'm wasting time.
Thermal energy. What it needs is a difference.
Blender, yeah. Then I try every single time. Because if there isn't something rendering in the background when I'm sleeping, I feel awful. I'm having nightmares and
Temperature, so a difference in thermal energies. Which means that if our generator was just as hot as the cube it sits, just as hot as the cube it sits on, it would generate no electrical energy. Even though both the generator and the cube are extremely hot, so they have a lot of thermal energy. Because of entropy, there's just no way to convert it into anything useful. That's why sometimes a system with more energy but less entropy can be preferable to one with more energy. Because there's just more useful work to be done. And that's why heat is the ash of energy.
Oh, right here I say heat instead of temperature. Whoops.
It's because when it comes to temperature, the energy is distributed so evenly that there's just no way to use it.
Okay, right here I want the music to cut for comical effect.
This explains
because I'm a hilarious person.
Pretty well why thermal energy is worthless most of the time. You see, high thermal energy means that these molecules have a lot of kinetic energy.
Okay, we
but
don't care about this.
Thermal, they are moving randomly, which means it's difficult to harness this energy in any meaningful way. That's why there's just no way to use it. That's why we differentiate between them. It's because whilst both thermal and kinetic energies describe movement, this movement is much easier to use than this movement. Hence, this is useful, and this, most of the time, is just a loss. Okay, so that's why we differentiate between thermokinetic. How about electrical?
Oh wow, this single render will carry me through a lot of minutes though. That's good. It's good. I feel like I'm speedrunning. Oh, now we're using the Make It shortcut. Well, how's the other animation going? It's pretty well, pretty good, pretty good. And here's the switch of music, if I'm not mistaken. There we go. You know what, like, take it back. I love having these two songs back to back. It's funny. Make it blend at any percent. Bro spent 2 hours and 5 minutes and feels like speedrunning. It's, our time is relative, you know? It's like...
It would generate...
Einstein said it, which means it must be smart.
It would generate no electrical energy. Even though both the generator and the
Okay, that's a pretty good graphic though. I'm happy with this graphic.
cube are extremely hot, so they have a lot of thermal energy. Because of entropy, there is no
Don't Einstein me.
way to convert it into anything useful. That's why sometimes a system with more
Y'all don't believe in me. Y'all don't believe that I can actually finish this in 5 minutes. Well, shame on you, because I actually will finish it in 5 minutes. That's all I need. I just need 5 minutes. That's all I need.
more energy but less entropy can be preferable to a system with more energy but less entropy can be preferable to one with more energy.
I say more energy twice. Whoops!
Preferable to one with more energy.
Whoops.
Because there is just more. Because there is just more. Because there is just more useful walking down. And that's why heat is the ash of energy. It's because when it comes to temperature, the energy is distributed so evenly that there is just no way to use it. That's why we differentiate between them. It's because whilst both them there is just no way to use it. That's why we differentiate between them. It's because whilst both thermal and kinetic energies describe movement, this movement is much easier to use.
Kinetic and thermal. Thermal is gonna be orange. There we go, but like a reddish orange. And kinetic is going to be blue. To contrast it, I suppose. Why is switching? No, switch kinetic.
Evenly that there is just no way to use it. That's why we differentiate between them. Is because whilst both thermal and kinetic energies describe movement, this
I will have to do a final run to check if the music actually works for the video,
movement is much easier to use than
because I haven't actually been checking the audio at all.
this movement. Hence, this is useful, and this most of the time is just a loss. Okay, so that's why we differentiate between thermal and kinetic.
No, let's actually check
How
it now.
about electrical?
Like, it's good enough.
Well, energy couldn't be destroyed nor created. And yeah, it can't. But the energy lost isn't really a loss of energy. It's energy lost as temperature. Machinery gets hot and the thermal energy leaks away. But why would we consider thermal energy as lost? Well, it's because temperature is the ash of energy. And here's where we introduce entropy. So what is entropy? Well, entropy tells us how much useless energy is there. Okay, that's cool, but what is useless energy? Well, imagine a hot cube, like really hot, scalding hot. Then imagine placing an engine on top of it. which turns heat
This
into
generator,
electricity.
not the engine, goes now.
Now, after placing this engine, we get electricity and we can use it to do work. In this case, I don't mean the human abstract kind of work, I mean the physical unit of work. Now, what's really interesting is that for thermal energy, when we use it in engines, we don't really actually care about how hot something is, only about how
There's so much
hot it
text
is
on the
in
screen because I
relation to
just
other
didn't know
things.
what to put in. Okay. Whoops.
Energy is distributed so evenly that there's just no way to use it. That's why we differentiate between them. It's because whilst both thermal and kinetic energies describe movement, this movement is much easier to use than this movement. Hence, this is useful, and this, most of the time,
Look how
is
close we are.
useless. Okay, so that's why we differentiate between thermokinetic. How about electrical? Well, if you think about this, kinetic and electrical also seem like the same thing. Kinetic
Oh my goodness gracious me. Okay.
How about electrical? Well, if you think about this,
What am I
kinetic
supposed to
and
animate for this
electrical
one?
also seem like the same thing. Kinetic is just the movement of something, and electrical is just the movement of electrons. So, why do we differentiate between those two? Well, it's because it's useful. If we differentiate between them, we can apply different equations, different models, and have the whole thing be more accurate. That's why when dealing with kinetic energy, the equations would look like this most of the time, and with electrical, like this.
No, this is dumb. I scripted this before ending the video, and that's actually the conclusion of the video, I just realized. Huh, hold on, let me check the script again. That's really dumb. That's so dumb. That is, wait, that is really dumb.
Okay, so that's why we differentiate between thermokinetic. How about electrical? Well, if you think about this, kinetic and electrical charge, so position in relation to electrical field, and chemical, so position of electron.
Wait, where's the speaking of segues segment?
Now, what's important to remember is that all of them are just potential energy.
None of them. Oh, well, that's what I was
there,
talking about.
that's the energy. And speaking of, so here's, so there,
That's,
that's
the,
the energy.
the greatest segue I've ever done. I just gave up. So there, that's the energy. And speaking of segues, let's talk about our sponsor. Oh, even the sponsorship would be a better segue. It's not snapping because I'm moving too many things.
This, most of the time, is just a loss. Okay, so that's why we differentiate between thermokinetic. How about electrical? So there, that's the energy loss. Okay, that's why the energy. And speaking of segues, what are these models actually like?
I didn't even refer to models. That's the problem. It would be actually really difficult for me to set up the segue correctly.
This, most of the time, is just a loss. So there. Most of the time, is just a loss.
And that's all fine and well in theory, but what's the actual practical difference between kinetic and thermal? Is that good enough of a segue? I don't know. It's practical-ish. It's not really practical. We're still doing theory, but...
Well, in theory, but what's the actual practical difference between kinetic and thermal? So let's start with force. I won't overcomplicate it
Wow, this is lagging.
with force. I won't overcomplicate it too much. If you have an object with mass m and you push it,
I love this segment actually because right here I say, I won't overcomplicate it too much, and then proceed to overcomplicate it for a fair amount of time actually.
then the stronger you push it, the more it accelerates. You can describe the strength of a push as F.
Okay, this is done.
Does that make sense? In order to understand that, we have to imagine two cubes. First one bumping it.
Wait, that's the animation we're rendering right now. That's this one. Cool. Oh, and this is finished. Sick. Alright. Oh. So we have 2/3 of the video done. Over 2/3, actually. Way over 2/3. We're getting there. It's fine. I can make it happen.
In classical mechanics, we took the force acting upon an object, multiplied by distance, and got the work done. We can do the same thing here. So we can multiply it by the distance and turn this magnitude electric field into voltage.
Big overcomplicated. Must have bought you out. You only get $5 a month. Hey, that's like almost the patron tier on Patreon.
Let's see where this is going. Back in classical mechanics, we took the force.
Okay, right here we're gonna need another animation. Which will probably once again take ages to render. Electrical, yes. And right here we're gonna start with. I'm actually gonna copy it, paste one, and right here we're going to go to the very end, like this. Start at 300, go up to 350. This animation will be so short, specifically because I do not have the render time to go for a longer one. So this one will be a quick movement. Not for any fancy specific reason, it's just because I don't have the time. So right here won't have electrical actually, we'll just have this equation. So Q and E. Well, right, it's Q and E. Yes, it's Q and E, okay. So instead of this, we're gonna need... I can't delete this, there we go. Oh, my taskbar broke again. That was... always really quick. Hold on, I can't find... Damn it! Windows, why are you like this? Ah... There we go, fixed it. Neat. Now all I need is Blender 4.0, because that's where I have the plugin to make it happen. That's not what I meant to paste in. There we go. And now both Q and E will both have the same thing, same material, and this material will be a bit more, bit tougher to make. It will basically be texture coordinate like this, and then object, I think. Separate XYZ, add X to Y, and then this into a color ramp like this. It's right here. Not object generated? No. Not UV, this doesn't make any sense. Object would make sense, but it's clearly not. It's not generated. Or maybe generated, but we're adding the wrong thing? The point is red. And this. And I do believe what I did last time is I walked this bit down, this bit down, and then deleted all of them, deleted this one, then added an emission with, which is just black. And that was a bit much. There we go. Electrical. That's not in the folder. Curious choice, make it one render animation. Right? Now we would like this to render quicker actually. Now that I think about this, we would like this to render quicker. Because the quicker this renders, the quicker I can finish the first one, then I can move on to the final animation actually. We are really close. Oh boy. Yeah, you know what, let's hold our horses with this one. And just wait for this one to render. How many frames is that? 2 minutes per frame. Good. 76. 30, so that's like an hour. Why? Let's do some shit posts on YouTube. Doesn't post something on Community Tab. The shitpost successful. Can I edit this actually? No, I would like to reposition the good enough. That's such a cool image though, damn. Once we get this done, we can begin this render and then also render all the transitions between them and the final animation. And those will not have a volume for most of the time, which means those renders will really be quick. It will be like 5 minutes per render, which is, well, kind of funny considering that, you know, it will just take me 5 minutes to finish the entire video, because just 5 minutes tops and then we're done. That's all we need, just like 5 minutes tops. That's all we need. Ba-ba-bum. 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 Hold on, I'll be right back. I'm back. I told you I'll be right back. I'm thinking of anything else I could do in the meantime. This is rendering. This will require a scene, which requires this one to be finished.
So that's the thermal energy. Well, one of them at least. And right here we can already see a certain pattern develop. You see, first we started with classical mechanics and this equation. Then for electrical energy we took this equation and modified it to account for charge with this equation. For radiant energy we did the same thing except with this equation for radiant energy we did this. For radiant energy we did the same thing except with this equation for radiant energy we did the same thing except with this equation to account for the lack of mass. For thermal it's once again the same thing except with this equation to account for the statistical nature of thermodynamics, and there is a reason for it. You see, this equation just tells us the capacity for work in normal everyday objects like balls or cubes or whatnot. But in the realm of photons or charge or average movement, this isn't enough. Because this is only true for the classical model of physics. That's the thing. If you think about it, work is just a concept. That's it. If you think about it, work is just a concept. That's it. Nothing more. We made up the concept of work to describe different behaviors of different things. Then we made up the concept of energy to describe how much work something can do. But we can't really simulate all of the atoms in a cube of iron and the intricate behaviors of the electron clouds and elementary particles intramolecular forces, intermolecular forces, and so on. And that's why we invent models to simplify things. Of course, nothing is free, so classical model may be simpler than something like simulating everything. Of course, nothing is free, so a classical model may be simpler than simulating everything, but it's less accurate for classical physics. But it's less accurate for classical objects. But it's less accurate for classical physics. But it's less accurate for classical objects. And if you apply it to something like photons, it breaks down completely. Of course, nothing is free, so a classical model may be it breaks down completely. There is no mass. That's why we need to modify it for photons. So that would be the point of this video. Energy is just a concept. Like anything else in physics, different kinds of energy may be treated differently, but they are just capacity to do work. And there is no better example than. So what is potential energy? Well, if we take a look at kinetic energy, we'll find a pretty straightforward explanation. In physics, the kinetic energy of an object is the form of...
Oh, we can do this one. That's a good one. That's a good one. Okay. What is potential energy?
So, what is potential energy?
Oh, I have an idea. Full circle. Hell yeah. This is gonna be cool, trust me. Oh, trust me, this is gonna be cool. We're gonna take the intro animation. This one. I'm gonna save it. Didn't have like a keyframe somewhere? No. I could have sworn had a keyframe. We're just increasing saturation. Oh no, that's the first one, that's right. Boy, that's an awkward text position. There we go. Do, 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 do.
So, what is potential energy? Well, if we take a look at kinetic energy, we'll find a pretty straightforward explanation. In physics, the kinetic energy of an object is the form of energy that it possesses due to its motion. Simple as it could be. Then we have this equation as sort of general...
Alright, what is potential? And then energy. Alright, now The only thing we're looking for is the actual screenshot we took. Do I even have the screenshot? I don't think I do. I think I have the script. Ah, I do not have it in the script. I actually took it from Wikipedia, might as well go there. Oh, wait, this, right. Kinetic energy. Right, and then potential. Nope, nope. Potential energy. For the Flash episode, see potential energy, the Flash. Hold on, let me delete this. Flash thing, clarity. Why is this image 0 kilobytes? That's shady.
So, what is potential energy? Well, if we take a look at kinetic energy, we'll find a pretty straightforward explanation.
Maybe let's change this up a bit. So right here, when we take a look at kinetic, let's change it to kinetic. Let's also do a backup case. I don't trust Premiere.
In physics, the kinetic energy of an object is the form of energy that it possesses due to its motion. Simple as it could be. Then we have this equation as a sort of general equation. Then we have
Right here in the equation. Damn it! This one. S squared, T squared. No, I did minus, doesn't matter, it's 180. I'm sorry, why is it going there? Use nodes, and then first we're gonna have the white one, then we're gonna have this one, which will be yellow, of course. Then we're gonna have this one, which will be orange. Then we'll have this one. I forgot about the M, didn't I? I've gone and bloody forgot about the M. I might as well create new one. There we go. We have this equation. Done. 10 more frames, which means 20 more minutes. Okay, it's fine though, because getting some good progress with the potential energy segment.
We have this equation as sort of general equation describing it, which we can modify it for different cases. But then we have potential energy. But then we have potential energy with different. But then we have potential energy with definition like.
Okay, so now, right here, we're gonna increase this in size, copy this right here, and right here we're gonna edit this to potential. And all of this, and then 75, and then at 75 we're gonna have the camera way. Oh, damn it! Way lower. And Rust, yes, this does mean 2 animations rendering all at once. This one will be way quicker because how long does each frame take? Each frame is 16 seconds, so 4 frames a second, 4 frames a minute. I mean, no, 4 frames a second, I wish.
But then we have potential energy with definition like this. In physics, potential energy is the energy held by an object. In physics, potential this. In physics, potential energy is the energy held by an object. In physics, potential energy is the energy held by an object because of its position relative to other objects, stresses within itself, its electric charge, or other factors. Other factors. That's so vague. What other factors? What kinds of factors? Gravity, charge, quantum nonsense? Well, all of them. For kinetic energy, we do not only have a concrete rigid definition, but also a general equation. But for kinetic energy, we not only have a concrete rigid definition, but also for kinetic energy, we not only have a concrete rigid definition, but also a general equation. But for potential energy, we have this, a function. What is this function equal to? We don't know. In order to describe it fully, you'd have to account for every single thing in this universe which might give you some capacity to do work. Physicists do differentiate between kinetic and potential energy, and there is a solid line between them, but that's only because potential energy is a bit of a misnomer. In reality, it should be kinetic energy for all movement and static energy for everything else. That's because all energy is potential energy. All energy is just potential to do work. All of the things I've described so far and more, like gravity and chemical energy, aren't connected by a solid line. They just all influence each other That's what existence is. Affecting something. All of the things I've described so far and they just all influence line. They just all influence each other That's what existence is. Affecting something, leaving an impact. Light, heat, charge, movement. All of these things are completely different, and yet we use a single term called energy to describe them all. But that's it. To describe them with different models, different equations, we try to describe these completely different forces into a single coherent science. And that's what physics is. Physics is the answer to a question of what is energy.
I would just like to bring attention to the fact that the music I've been playing in the background for the stream lined up perfectly to this. Alright, cool. So, oh my god, we're almost done actually. 5 more minutes tops. Because this one won't take all that much. That'll be just a couple of animations. Oh, it has motion blur, that's sweet. But just a couple of animations. This one will take actually also not that much. That will be just an animation in the dark room. This one will take a bit. Yes, that's true. That's the first one we're tackling. So, once we are finished with this segment, we're really close. And I mean really, really close. Oh, but then we also have to add sound. That shouldn't be that difficult. You know what, let's modify the electricity segment already, because...
I think you can see where this is going. Back in classical mechanics, we took the force acting upon an object, multiplied by distance, and got the work done. We can do the same thing here, so we can multiply it by the distance and turn this magnitude electric field into voltage. Now we get the energy equal to voltage times charge. What does that mean? Well, imagine a magnet. What this equation says...
Okay, so when it goes to the electrical one, right here we have FQE. But in reality, this should be FQV, EQV in the end. That's when we want to modify to energy. So let's get another one. It will be E equals to QV. This is for the energy. There we go. Don't save it. No need. Extrude a bit, and then copy all of these settings right here. Right, so this one needs material 5. This one, there we go. And then E needs a new one, which will be yellow. Then we can make it disappear. There we go. That's how it will be. And then right here on the ground we can have a red cube. Like this. With a voltage on top of it, so in this case voltage would be the electric field, as in magnetic, sorry, because it's an analogy. That's wrong. And volume. Principled volume. Oh boy, once again I'm adding a volume because of course I am. And in this case actually it fits. There we go. And this red cube right there is supposed to be our magnet, and the thing around it is supposed to be our field. Four frames left. 5 minutes set. This is gonna be just 5 minutes. That's all it takes. Okay, I just need 5 more minutes and then I'm done. That's all I need. Just 5 more minutes. Right? Just give me 5 more minutes and then the video will be finished. It's been 2 hours. No, I've just been warming up, okay? Now it's gonna be just 5 more minutes and that's it. That's all I need. 5 more minutes. Tops. 5 more minutes tops, and that's it. Okay. we have made some progress though. Quite a lot of progress. Oh, is the other one doing, by the way? Oh, 21. 2 minutes? How? In what universe is it taking 2 minutes per each frame right here? 49 seconds. Yeah, that's... Oh, they oscillate. They just have... Okay. Five minutes, precisely. Trust, exactly. Just 5 more minutes. That's it. Last frame of this animation. Hell yeah. And there we go. Cool, now we can import it right here. Eat.
The force, the quicker it accelerates. First one bumping into 2 cubes. First one bumping into the other one. First one bumping into the other one. Both of these cubes have their own mass. This cube is traveling at a certain velocity, so it has some sort of momentum. These cubes have their own mass.
Okay, and right here we won't do animations, we'll do single frame renders. Not only because they are faster, but also because with animations it would just be more confusing in the end. So let's do it like this. Let's delete all of the frames. All of the frames. Sweet. Now we need this arrow. Right here. Then motion blur over 2 frames. Center frame, yes, and 1. Then we're gonna need cylinder. That's the force. right here. And this will be the acceleration. So right here, that's our setup. That doesn't look much like motion blur, actually. That don't look too motion blurry. That's motion blur. This is nothing. Ah, my eyes hurt so much. Oh my goodness. Sweet. Hell yeah, 5. There we go. And just one by one, we're gonna get there. Just 5 more minutes. So I need just 5 more minutes. Just 5 more minutes.
This cube is traveling at a certain velocity, so it has some sort of momentum. On mass, this cube is traveling at a certain velocity, so it has some sort of momentum. Now when it hits this cube, it accelerates. Now when it hits this cube, it accelerates. And that's where our equation comes in handy.
Alright, so what we need is narrow, which I do have right here.
Certain velocity, so it's on mass. This cube is traveling at a certain velocity, so it has some sort of momentum. Irrelevant. Now when it hits this cube, it accelerates. And
I
that's
can like delete this. What? There we go.
now when it hits this cube, it accelerates. And that's where our equation comes in handy. It basically says that the higher the force,
So, yeah. I want this one. So I want this one, we want this one at like 7. Is it too bright or is it just bright enough? Feels just bright enough.
equation comes in handy. It basically says that the higher the force, the quicker.
And now I'm gonna need something that I haven't used in a while, which is sound effects. Oh, it can't play this.
Hydrogens. Oxygen atoms bonded, carbon atom and 2 oxygen atoms bonded together, but what? The force, the quicker it force.
There we go.
The quicker it accelerates.
Right here, and the quicker it accelerates, what it means is we take this, we turn that back to 1, we turn this to 7, we turn this up to 7, we turn this up to 7, we render this. There we go.
The force, the quicker it accelerates. So the more meters it can cover while it's accelerating, the shorter the time for a certain acceleration accelerates. So the more meters. The quicker it accelerates. So the more meters it can cover while it's accelerating, the shorter the time for a certain acceleration to shorter the time for a certain acceleration to occur, and the bigger the mass it can occur, and the bigger the mass it can accelerate. That's why all the units are there. Now we understand force, we can get to work on understanding work. So
Okay, so this acceleration.
accelerates.
Okay, acceleration.
So the more meters it can cover while
Acceleration
the
distance.
shorter the time for a certain
Time.
acceleration to occur.
So
Cover while accelerating, the shorter the time for a certain
distance times mass. Distance time mass. That's the order. Now we want distance, so we turn this off. All things considered, actually, it's going really well. Really, really well. And we need time. So this to 7, this to 1. And now the switch in melodies, if I do remember correctly. Right, it's gonna be now extreme. There we go. Hell yeah. Wait, what's the next frame like? I'm sorry, my file explorer just broke. Oh, that's great. There we go. Took you long enough.
Quicker it accelerates. So the more meters it can cover while accelerating, the shorter the time for a certain acceleration to occur, and the bigger the mass it can accelerate. That's why all the units are there. Now we understand force, we can get to warp. We can get to warp on understanding. On understanding walk. So what is walk? Well, walk can be defined as distance we push this cube over. Okay, well, it's not quite the distance itself, it's like the amount of distance the force acted on, so like how far we pushed. So force multiplied by distance, that's walk. So how far we pushed, but pushing is like a central part. It's force times distance. So it's force times distance. So imagine and make it intern pushing it.
Oh my goodness, this is the last one. Alright, electrical. So if this is the last one, might as well render the electrical one. Not wasting time.
Acceleration will occur, and the bigger the mass, it can accelerate. That's why all the units are there. Now we understand force, we can get. Now we understand force, we can get to walk. On understanding walk. So what is walk? Well, walk can be defined as distance we push this cube over. Okay, well, it's not quite the distance itself, it's like the amount of distance the force acted
Whoa,
on.
that was a scary lag.
Pushed, so force multiplied by distance, that's walk. So how far we pushed, but pushing is like a central part. It's force times distance. So imagine and make it intern pushing a cube.
Right here, this cut strip snap
Force
here.
times distance. So imagine and make it intern pushing a cube. This make it intern is actively walking, which means that
Okay, this is nice because we can make a much easier to render animation of this. And I mean much easier to render. We can just delete this, 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 delete this. Delete this, which is most important, because deleting that will actually remove the volume, which was taking up so much. Oh, we delete also all of the keyframes. So much of the render time. From 0, let's do to 60. I will need to find a perfect spot for me to tile it. You'll see what I mean soon. Oh, I guess this will do. 91. Okay. Oh, but that would be a bit too quick, wouldn't it? That would be way too quick. I'll make it smaller, no. What if I make right here this way larger, and then make these bigger? Why Where's the cube? Down there. What? No, don't. That's the dumb way to make it bigger. That's not what I meant. I meant active element. Bigger. There we go. Okay, so the size of this is 91 times. I'm assuming and hoping it's 91 times 1 meter, because then we could add this right here. No, that's wrong. I meant this right here. No, that's also wrong. I meant this right here. There we go. Move this keyframe to 100. And then mark 0. Then take this cube, point it to the camera, and this should be a perfect loop. No, it's not. Why? Because it's just simply not perfect. Okay, we have like a circle right there. Turns out the end of the cube. Is this the one? No. Don't look like the one. That's because I'm not tiling it correctly. I'm an idiot, that's the one. Oh no. Still not really. Hold on. Generated, yeah. UV. That shouldn't matter, should it? Oh, hold on, we're in the wrong spot. Fudge. There we go. Now it should be a perfect loop. Hell yeah, okay, cool. Now we can get a make it intern in here. It will be just a make it intern. We don't make it intern. Poses. This one. Make it as intense powerful so they can just... They don't even move their feet, they don't have to. Make it in them. Right, so one bit back, one bit in front, down. Put your back to it, you know, like this, like this. Okay. There we go. I'll take Q. Punch in the box. What is potential energy? Okay, this is rendering. No, this is the rendering. This. These two are rendering, we can work on this one, right here.
Describing it, which we can modify it for different cases. But then we have potential energy with definition like this. But then we have potential energy with definition like this, in this, this. In physics, potential energy is the energy held by an object because of its position relative to other objects, stresses within itself, its electric charge, or other factors. Other factors. That's so vague. What other factors? What kinds of factors? Gravity, charge, quantum nonsense? Well, all of them. For kinetic energy, we not only have a concrete rigid definition, but also a general equation. But for potential energy, we have this. Have this.
And there we go.
Energy, we have this, a function. What is this function equal to? We don't know. In order to describe it fully, you'd have to account for every single thing in this universe which might give you some capacity to do work. Physicists do differentiate between kinetic and potential energy, and there is a solid line between them, but that's only because potential energy is a bit of to do work. Physicists do
200 too many? I don't know. It probably is. Let's go back to like 150. Now how to do this? Smart way. There we go. Now I have the audio in the background is necessary. Oh, we're rendering 3 at the same time. Cool. Let's pause this one. The electric one. This one is the one I want to finish first. Because once we're done with the general one, we can do the black room one, and then actually one bracket there. Oh wow, how's the progress looking? This hole, this hole, this hole, and this hole. 4 holes which we have to fill in, and then it's really cool. Taking this one too, I suppose.
And make it intent pushing a cube. This make it intent is actively walking, which means that the work being done is equal to the force of the intent pushing multiplied by the distance the intent is covering. But how does that relate to energy? Well, energy is the capacity for work, which means that in this case, this is the equation for energy. Kinetic energy of this cube. Now this example is a bit tricky because we have our make it and then pumping new kinetic energy into our system by pushing the cube. And the cube is losing so like how far we pushed, so force energy is energy is the capacity for work. The energy of this cube. Now this is the equation for energy. This is the equation for energy. Kinetic energy of this cube. Now
I need to wait for this to end now. 33, it's not 50 minutes. Oh, isn't there a way to speed this up? You know what? I could actually loop it quicker. You know what? Hold on. Let's think about this. First of all, motion blur. If I want to do it with motion blur, I can't do it in the center. I have to do it in the start. Yeah. Second of all, we don't need to do it for 100. You can do it just for 50. That'll be easier. And then render again, and then we can also turn this off in the background. Speed up. And now should take less time to render. You know what? I'll be right back. I will be right back. Hold on, let me just... can I duplicate? Thing, copy. Oh, sweet. There we go, professional stream. I'm fine, I'm good, I'm back. It's gonna be done in 5 minutes. Yeah, I am. Are you streaming till you're done? Probably. Hopefully. Hi, the call. Welcome. Hi. I'm back. Well, the perfect timing I have. Right when the render finished. I think we don't need the frame 50 actually. Electrical, let's render this. So, models, and now he's finishing in 5 more minutes, precisely. That's precisely what's going to happen now.
It's force times distance. So imagine a make
5 more
intent
minutes.
pushing a cube. This make it intent is actively walking, which means that the work being done is equal.
I should do the walk bit. Just messed up accent. I move it right here. I know. No, that's bad. Let's 4. Sick.
Which means that the work being done is cube. This make it intent is actively
White and in the center and higher up. And larger. This.
walking, which means that the work being done is equal to the force of the intent pushing multiplied by the distance the intent is covering. But how does that relate to energy? Well, energy is the capacity for work, which means that in this case, this is the equation for energy. Kinetic energy of this cube. Now, this example is a bit tricky because we have our make it and then pumping new kinetic energy into our system by pushing the cube. And the cube is losing the energy as thermal energy because of friction. But that's the equation for kinetic energy of the cube. So the work it's doing. Now it's time for the electrical energy equation. And so for electrical energy,
Right here.
now it's time for the electrical energy equation.
This is what we're gonna list. We're gonna render it out quickly for the black room animation. How you doing? Hi there, Happy. How you doing? Good. All those colors. Black room. Because that's precisely what was gonna be. Nested sequence 10. Yeah, my naming is great. MP4. Sick, sweet. Now we can delete this nest. We don't need it anymore. And Blender 4.1. Last setup to an animation. Another thing we'll have to do, which I completely forgot about because of course I did, is as poses. That's incorrect. I made the hot one black room entirely good enough. Will be a thumbnail. We'll have to make thumbnails for this video. Completely forgot about it. I always forget about it, and then in the end, I just have to make something up on the spot. There, pitch black. Add in images as planes is gonna be a video, not an image, and then right here, plug this bad boy right in there. There we go. Start parented. Let's rotate this a bit, I suppose. Oh, you know what? Let's not. How about we not? How about we don't? How about we just keyframe? Oh, the 100 go up. How much time is left? I keep checking and I find you are still doing the same thing. So, Alex, we should go try some finals. No, there's just 5 minutes left. If you're asking how much, there's just 5 minutes. That's all I need. Just 5 more minutes and then we're finished. Okay, that's it. Just 5 more minutes. So it should be pretty straightforward. Import images. No, add images is plain and simpler. There we go. And then we're gonna need is start all of the different animations. Which mean potential frames. No, not potential. Models frames. Electrical. Yes, this one. I could just add all of them. There we go. Simple as it could be. Now we have all of these. Why is Temu all of a sudden? Oh, you all have the same. Why do you all have the same material? That's so incorrect. This one isn't supposed to be Temu. This one is supposed to be Radiant. And this one isn't supposed to be Temu. This one is supposed to be electrical. There we go. And now, actually, the height of all of these should be constant. That would make the whole process way easier. There. The camera should go up. No, it should go to electrical, which means it should go up originally, like right here. It should go up, and then it should go down to the electrical one. Gradient film really? We did only 3? Okay. This opened up hot black room frames. All right. So, let's play some music. Yes, I've pretty much played the finals. We're getting there, we just need to finish the video first. Okay, but speaking of, actually, another thing which I have to do for the video, which I always forget, is the thumbnail. So since we are rendering these two right now, might as well make the thumbnail in the meantime. For the thumbnail, the way I usually do it is I just pick some nice looking scenery, like for example, this right here looks pretty nice. I open it up. Break on like a lunch break. I would love lunch break, don't you think? No, I'm so close to being done though. Why would I take a lunch break when I'm this close to being done? Like it's unbelievable just how you wouldn't even believe just how close to being done I am. I'm so close to being done. In fact, I'm almost there. 90. Negative 90. No, this is the green one. So the green one is energy. Then we should have. Is it good enough for a thumbnail? No, this is garbage. You said that like 3 minutes ago. No, I didn't. No, I mean, just 5 more minutes. Happy, give me just like 5 more minutes, okay? 5 minutes tops. Okay, so what I want to do is I want to parent all of these to this one. Clear keyframes, clear keyframes, clear keyframes. Move it back like right here. Like this. Instead of those, we'll just move them back too. We'll have demo. It's a very messy thumbnail. Oh well. Right, potential energies. Maybe we'll go take a break, goddammit. I will, once I'm done. Once I'm done, I will take a break. I just need to finish this real quick. Radiant. Kinetic. Listen, I'm like 5 more minutes, 5 minutes tops and I'm done with the video, right? Why would I take a break now? Does that demo, kinetic, radiant, electrical, right? Impression after these long hours ain't gonna be fun. Wait, is YouTube deleting comments with your depression in it? Oh, that's great. That's so dumb. That's an awful word to ban from comments. Oh no. Why is the be right back in the corner? This should say 516. Oh, because I copied them. No wait, this should say day. There we go. Radiant gravitational, what else is that? Chemical. That's all I can remember. So we can have then the cube, because this is a thumbnail, which means only one frame, which means we can go crazy and add like a volume. This one's a bit off. It's really messy, but oh well. I should talk about being sad. Now I just bought Love Inside. This comment was brought to you by Mental Health Pharmaceuticals. Hey, wanna not be sad? How about you take our pills instead of going to therapy? The ball is not... Wait, where's the... Who took my ball? Ball? Stay there. There we go. Is this good as a thumbnail? Would this work? Energy. No, feels off. Ah, well, that's why. Fortunately, there was a feature for this. I'll look in the other renders like this one. It's going. Up. Let me get a sip of coffee. That was the last sip actually. And there, my 2-liter large cup of coffee is left empty and dry. Wait, is Steph still here? Tastes like a heart attack. Oh, come on. It's just coffee. I'll have to drink a lot of it. I mean, a lot of it to actually have a heart attack. Ah, good enough. That's thumbnail 0. I'm gonna render it as JPEG. Make sure that YouTube will allow it. That's thumbnail 0. Now we're gonna need the other ones. This I just posted the video. It's great. Wait, did? Whoa, whoa, whoa! Did they have to really? Hold on, let me check. Wait, I got notification. Hell yeah!
Let's take a look at a 16 by 16 RGB matrix.
No content stealing. No, I'm not
Sold
gonna.
for about $20 at Walmart. I wanted to open it up, see what it does, and see if we can make some improvements.
Hell yeah! If y'all wanna watch the video, watch it yourself. I'm gonna spoil it. I'm gonna watch stuff for the stream though. Alright. So another decent thumbnail I could make. Could be with the black background one. Hold on, let me open up the black background pane render, which is what I lovingly called oh, where is it? I think it was in transformation. Yeah, this one. It takes ages to render. And then let's save it into the thumbnail as T1, and we're gonna modify it to have all the different energies, all the different kinds of energy right here. So we have this, which is okay, I like it so far. So far, this is basically chemical chemical, actually. When is it gonna become day 517? Yeah, that's what I was asking if Theta was there, because... Theta. Would you like to play finals in our... Okay. What other kinds of energies do we have? Thermal, which is this one. Can I make this larger? Oh hell yeah, that's a fireball. I think that's totally gone. Yeah, no, I know, that's why I messaged them on Discord. Right here, when it comes to these little suckers, we'd add more of them. There we go. Then what other kinds of energy do we have? Radiant, which could be with solar panels actually. This is yellow. Let's do... saturated yellow. And then right here we're gonna have just like a something that represents light, like this, and then to represent light we could have a spot actually. Let's not overthink this, just a spot. I was playing the finals. Oh, what a coincidence then! I just need like, all I need is like 5 more minutes to finish the video, and then I'm gonna, and then I'm gonna go and play this, and then right here another arrow like this. This will represent the fusion. Ah! That's Google warning me. Cool, thank you Google. That was really loud. Alright, this will take long enough. Name my video on today's from inception to finish. Yeah, I saw! Well, I saw the first 5 seconds, don't want the content steal. Your editing stream helped motivate me, well, I'm really glad then. I'm really glad it did. At least I'm glad it did something, because I sure as hell didn't make a video yet. For me. So far, all of my editing streams then have succeeded in helping to make more videos for you than for me. And that's a mathematical fact.
In the classical mechanic.
Did anything render yet? No, this one is still going. Cool, good to know. What's this one doing? Very slowly. By the way, if you'd like to join voice chat, chat about anything, feel free. Or maybe I could. Speaking of, I could actually record the final segment of the video.
Science.
Oh, that's a good idea. I can record the final segment of the video actually, because I haven't really yet. The ad segment, or as I like to call it, the maker is having a mental break segment. Okay, what should I say in that segment? We might as well complete it. Take your time. I still need to recall one more thing I forgot about. Alright. And so there. That's the video. Oh, hold on. I hadn't really finished, so I shouldn't really zoom out. Hold on, yeah, my head is empty. I need to think of something to say for this segment. And that's the video. I really hope you enjoy. Okay. And so there, that's the video. I really hope you enjoyed this video about energy, a bit of physics. And fun fact actually about this video. Yeah, this is the ad segment. This is the maker is having a mental breakdown part of the video, and that's because I stream every single day. Right here, you can see on screen all the thumbnails for the streams. I have a pretty fun idea for the end of this video. Hold on, let me show you what I mean. And so, it'll be pretty fun. Still streaming, 5 more minutes. Yeah, just 5 more minutes and it'll be done. Y'all don't believe in me, do you? That's gross. I'm just telling you, just 5 more minutes and then we'll be finished. And so there, that's the video. I really hope you enjoyed this video. And so there, that's the video. I really hope you enjoyed this video about energy, a bit of physics, and fun. I have a really fun idea for the ending of this one. Fun fact actually about this video. Yeah, this is the ad segment. This is the maker is having. Hold on, we can't just have the flash on screen because there's just too goddamn many of them. It's gonna be awful to watch. Mental breakdown part of the video, and that's because I stream every single day. Right here, you can see on screen all the thumbnails for these streams. Yeah, I have okay, there we go. And now. And so, fun fact, this entire video actually has been made on streams. Yeah, multiple, because it actually took weeks to make. Literal weeks. All of the live streams from me making this video are on YouTube. And if I sound a bit off now, that's because this is actually the ending of the final live stream. We're currently 5 hours in. There's still a couple of animations left to finish. So if you'd like to join me on any of these live streams, then go ahead and join. I stream literally every single day. Also, I have a Patreon in case you'd like to support me. A couple of tiers, fun tiers. Like, for example, you get to decide what the new Make in the Corner should look like. And Discord. I also have a Discord server in case you'd like to join. Anyhow, subscribe, like, and I suppose that'll be it. That's the second recording. Now, time for the third one, for the switcheroo. Oh, why is this one so weird? Why? Is this the only one screwed up? I think y'all can see where I'm going with this already. Yeah, but enough 5 minutes for you, 5 hours for me. Is for these streams.
And so, fun fact, this entire.
Okay, there we go. There. And now what I want to do is I want to overlay them perfectly. Ish. Okay, the best way for me to do this would be to move the anchor point to this corner right there, actually. That would be the best way for me to do this. Hold on, where's the anchor point? Right, move the anchor point to the corner. Yes, then increase in size. The exact spot. Yeah, I'm a professional. And now if we do lighten, this should overlap perfectly. Hell yeah.
And so, fun fact, this. And so, fun fact, this entire video actually has. And so, fun fact, this entire video actually has been made on streams.
It's the dumbest, bro. I'm doing this.
Because it actually took weeks to make. Literal weeks. All of the live streams from me making this video are on YouTube. And if I sound a bit off now, that's because this is actually the ending of the final live stream. We're currently 5 hours in. There's still a couple of animations left to finish. So if you'd like to join me on any of these live streams,
Inception moment, indeed.
go ahead and join. I stream literally every single day. Also, I have a Patreon in case you'd like to support me. A couple of tiers, fun tiers. Like, for example, you get to decide what the new make in the corner should look like. And Discord. I also have a Discord server in case you'd like to join. Anyhow, subscribe, like, and I suppose that'll be it.
Thank you everyone so much for watching, and have a great day. Bye. And boom, ends the live stream. Nah, we still have work to do. We ain't finished. We ain't done. That's only for the people watching the video. Make it. Did you spend 26 hours on this video? Or something like that. I don't know. I have to count all the live streams. And depending, wait, would you, because I have, well, depends how you would count it too, I suppose. I have a lot of live streams which were about different things, but then I segued into making a video. 5 more minutes. Precisely, just 5 minutes. 5 more minutes. That's all I need. All I need is 5 more minutes. That's all I need. Could you mind just tossing me a 5, you know?
Thank you, everyone. So much.
Just toss me a 5. That's all I need, okay? Can I copy these and paste them right here? No, Premiere is not smart enough for this. Oh, never mind.
Thank you, everyone, so much for watching. Thank you, everyone, so much for watching. And have a great day. Bye.
Bonk. Haha. Kind of, but not exactly, give or take 30 minutes. Yep. Haha. There, now we're finished with all the recording. Oh, sweet. This is also rendered. Sick. That's great. Because that means now we can add it right here, because that's where it's supposed to go. So import hot blackroom frames 0 this.
And so for electrical energy, we're talking about electrons and their movement. So for electrical energy, we're going to start with this. I won't re-explain how to get this equation. And so for electrical energy, we're talking about electrons and
Oh yeah, you can see it. Ew. It's a bit of an ew. Let's add a frame hold. Let's have it cross dissolve.
Electrons and their movement. So for
Good
electrical
enough.
energy, we're going to start with this.
Good enough. Also music. We need music for this.
Then so we push this cube over. Okay, well, it's not quite.
And for music, we're gonna need to open our A music folder and then pick up the cinematic jazz. Or maybe rather some. Oh wait, do I have like a cool make it now? This one. There we go.
Force times distance. So imagine a make it intern pushing a cube. This make it intern is actively walking, which means that the walk being which means that in this case, this electrical energy equation. And so for electrical energy, we're talking about electrons.
Ah, there's Sharma. Welcome.
So for electrical energy, we're going to start with this. I won't re-explain how to get this equation here because that's a story for another time and another video. So for now, you'll just have to trust me with this equation. I won't re-explain how to get this equation here because that's a story for another time and another video. So for now, you'll just have to trust me with this equation. Equation which says that the velocity of our electrons is equal to the charge multiplied by the magnitude of the electric field.
If these are clean for you, thank you. I'm assuming that's a compliment, and you're not just saying that they're empty.
Both sides by time, we'll get acceleration equal to this, and if we multiply both sides
By mass,
we'll get
it's
force equal to
this.
this.
So
I think you can see where
charge
this is going.
times
Back in
magnetic
classical
field.
mechanics, we took the force acting upon an object multiplied.
Yeah, and this is the rendering. That's this one. Wait, are we 2 frames away? Oh, it's quick. Oh yeah, because we did only have 50 frames, didn't we? Hold on, we just... Oh wait, if that's the case, then we can render this. Because we already done almost done with everything. Oh no, this one's also the rendering stuff. Oh, I'm so, by the way, glad everyone's joining in because we're almost done. Just 5 more minutes tops. Yeah, precisely. Yeah. Hell yeah. Okay, so this one's rendering.
The radiant energy being related to the wavelength. Why is that?
Oh wait, yeah, that's a good one to render too. We need... That's this one, I think. So we need to save it as a copy, and then right here... Oh, we're gonna need... Fudge sticks and shucks. This one has a different Y. Except that's the wrong frame. We don't want to end this on that frame, we want to end on another frame. I'm assuming it will take me an hour to render all of these. I'm hoping. Ice Pumpkin. Hi there, Ice Pumpkin. Welcome to the live stream. How are you doing? How's your day going? How are you doing? Are you having fun this Sunday? Resting up? I haven't seen Feeble in a long time in your streams, have you? Oh boy, Shama, that's... How many months ago was that? Shama, I've got some news for you. Feeble left. Yeah, and that is quite some time ago too. I only now realize how the force, the charge, and the E really nicely play as the background. That's nice. What do you mean? Boy, Shaw left. Yes, left. Yeah, I think you're wrong about the importance of meme irony. Doesn't matter. The only thing that matters if it makes a person laugh or children know how to use jokes and memes. I have no idea what you're referring to, Happy. I think you are wrong about the importance of memes. When was I talking about importance of memes? I don't know. I don't know what I was even. No clue which one you're referring to, Happy. You can't just say things without context. You have to say more, you know. Shama, it happened months ago. I don't remember. So I created the cause debating podium, and Feeble was upset with the fact that I like wasn't gonna moderate it because I said that, you know, it's the channel was meant to be controversial. People should say controversial stuff, and then Feeble just left. It was a clash of ideas, basically. At least a bit of it. There we go. Is Feeble ever gonna come back? Well, she hasn't after months, I don't think so. What about Hungry Apple? And Hungry's still around. Wait, Shama, how come you know about Feeble but don't know about her leaving? That's odd. There we go. Electrical. Opened.
Next, we took the force acting.
Yes, this was the last force.
Mechanics, we took the force acting upon an object.
Boy, my Premiere is glitching out. It's really not liking the way I use my GPU.
Multiply it by distance and got their work done. We can do the same thing here, so we can multiply it by the distance and turn this magnitude electric field into volt.
Do you talk to people in the DMs because you're still mutual friends? No, people doesn't really. This one, there we go. Appleman still pops in occasionally. What do you mean pops in occasionally? Appleman pops in quite often. Really often, I would even say. Go. Feeble left, she was like the most active person on there. Shama, as I mentioned, this is really old news. I mean, Krish already beat Feeble. And hold on, let me show you. Give me a second. Rank. No, not like this. Rank. Close enough. No, wait. Top rank, how do you do it? How do you all do it? Top. I see. Top. So much low was on. What do you mean so much? I mean, hold on. Let me show you. Oh, I have 100,000 experience. That's cool. Look! Feeble was second. Krish beat her. Krish just has higher experience now. Wait, is the E energy but the other is electric field? Yes, Ice Pumpkin. I am fully aware of how upsetting this notation in this case is, but I just simply don't really know how to play. Where am I? What do you mean, where are you? You're asking me? Why are you asking me? Not there. You don't have enough experience. Even Happy is there. Well, not even Happy does like a lot, but yeah. And Happy is gonna overtake Feeble too soon. There we go. Energy, finally. Is that the right one? No, electrical, yes. Oh, I forgot how big of a mess of a folder I made here. Alright, whatever. This, and then...
Hey, how's it going?
Hi, the Tefta. Hi, how you doing?
Good. I just was able to hook up the output audio from my Xbox to my
into
computer,
voltage.
so I could hear
Now
the
we
game
get the
too.
energy equal to
Oh, that's great. Listen, I'm gonna play. I just need 5 more minutes, okay? I just need 5 more minutes to finish the video, and that's it.
That's fine.
Yeah, just 5 more minutes, okay? Tops.
into voltage.
Well, I
Now
can
we
play
get
the
the
finals
energy,
while you're doing whatever.
You know what? Go right ahead. You have to play pretty quick, as I mentioned, only 5 minutes, but you
Now
know.
we get the energy
Yeah.
equal to voltage times charge.
Sure.
What does that mean? Well, imagine a magnet. What this equation says is that the stronger the charge,
I will have to try not to cuss though, since I'm on chat.
Oh no, I mean, you mean not cast because of the stream or because of the finals? Because if it's because of the stream, go right ahead. You can. It's fine.
that's
No, it's just the finals makes me want to cuss.
that's
I was like yelling at the screen. I'm like, oh wow, I'm pretty vocal.
Oh, don't worry.
When I know no one can hear me.
Don't worry. I'm a professional. I'll. You won't have to cast with me.
that's electrical energy. Next,
Good. I'm almost done. I'm so close.
So close.
I would like to play some finals now, though. I'm really in the mood. Or maybe I'm just done. There's just I'm probably just fed up with this video. I've been working on it for almost a month now, on streams. Five more minutes, trust. I know, Link. I know, just 5 more minutes. We really need 1%, we are stuck on the 99. To be fair, all of this is finished.
and we merge it with the ideal gas law equation. There. So that's the thermal energy. Well,
Okay.
more electrical energy it has, and through acting on it, or the stronger the charge of the magnet.
So I'm gonna charge the minus. Good. I really am curious of this video because my last the election video performed really well. It's now the second most famous video on the channel, and this one feels similar. It's also 20 something minute long just for the animations, and also starts with the word "elle." So, yeah, I mean the phrase "elle." So.
How many views did the other one get?
12,000.
What's it at now?
I think 12,000.
Nice.
Yeah, which is the second most famous video on the channel. 12,000. Right behind that one video, which has 500,000 views. It's a bit of a jump. Alright, there we go. This is to represent the charge, and then other one, which is to represent.
Well, this match is going to be short because I have 2 lights on my team.
Oh yeah. That is a pretty solid
It
way
was
to
a-
tell.
It was a medium, or sorry, it was a heavy and a light, and I was a medium, and then the heavy turned into a light for some
There
reason.
certainly is a there certainly appears to be a correlation between like a loss frequency and the amount of light a team has. There is certainly a correlation there. I'm a light player, I would know. Wow, this is fun. It's like watching paint dry. Actually, I just realized how good of an analogy that is. I am
Yeah.
watching a single frame getting rendered over 2 minutes. I'm not watching paint dry, I'm watching a painting dry.
The Cycles engine,
Yeah.
18 pixels of ray traced photons, virtual photons.
It's 200. I don't know if samples, like each sample is each ray per pixel. I think something like that. Which basically means the width of an image times the height of an image times 256, which quite a few rays, I would say.
Yeah.
Alright, but there, okay, one of them finished. It's actually really nice because when one of them is done, then the others get a pretty significant speed boost.
magnet, or the stronger the potential. Acting on it, the more electrical energy it has. That's what happens in our cables, except instead of a magnet, we have electrons, so that's electrical energy. Not quite magnetism, whole other kind of was. The point is, that's electrical energy. Next, we'd have
Alright, there we go. Done. You. Yeah, I'm just watching a painting dry and I'm switching from one painting to the other when it's done. It's cool. It's really cool. I mean, I like the finals, but you know, this is just as fun.
Looks fun.
So, anything else fun happened recently for you?
For me, a lot. Yeah.
Hmm. How many things I can actually
Uh,
talk about publicly?
yeah. So publicly, I'm working on that coffee clicker. That's pretty cool. I'm making it into a blockchain
Mm.
because a lot of people are talking about voting via blockchain, and it's actually a good use of the technology, and a peer-to-peer network, decentralized. And plus, I have to use the hashes for the gossip protocol. Anyways, I thought it'd be fun to just implement a blockchain for it.
That's actually so
So
basically, instead of proof of work being useless, you
Proof of
would.
stake. It will be proof of stake, and proof. The reason being is because you are part of a board meeting.
Yeah, you don't.
So
Really
I'm
need.
trying to have it.
That's
yeah.
fair. Huh. That's funny. I feel like 2 streams ago we had the conversation about when playing the finals. we had specifically this conversation about how like uh, cryptocurrencies are dumb, but the technology is cool, and then just
Yeah.
2 streams later.
So I can't do the asymmetric encryption on the devices because the ESP-NOW protocol only allows for 250 bits. But it is kind of fun. I'll still have a blockchain nonetheless and test different types of blockchains for voting systems because I think it'd be cool.
That's so many smart words, by the way.
Yeah. Oh, what's crazy is I had this $1 billion idea actually for a dual purpose blockchain that I'm working on. And that's with like a group of friends of mine that were just entrepreneurs. So who
Knowing
knows?
your projects, when you say $1 billion idea, I know it's a saying, but like knowing you, knowing your project,
It really is. I don't know if it's doable, but I'm gonna do some research. But it's kind of cool because I have some friends that are interested in working together on projects. So it's exciting. And my mom is doing fine because last time she had surgery, it was
also
crazy, hectic. She ended up having to have 2 brain surgeries back to back, but she is okay now.
I'm really glad to hear.
Alright, remember what.
And then my video of the LED matrix,
Yeah, I'll have to
'cause
watch
I
it after
found
the
it
stream.
$20 at Walmart. And I was like, no
That's
way
the
that this
way.
is functional, and it was. So, uh, but I need a break.
Well,
Took a vacation,
then.
a 2-day vacation, and I got called into work both days, believe it or not. Yeah.
Well, then this isn't quite a vacation, but I'll
We
be glad to
Alright,
help you as a
remember what I said
with,
about the
as a
radio?
distraction. I can't say I can't speak. I'm editing and listening to myself talk. It's like talking with a speed jammer, honestly.
Yeah.
I just hear my own voice on playback.
My light teammates probably hate my performance, but
Their lights, their opinion
Exactly.
doesn't matter.
well, to them, their opinion is the only thing that matters because they're light.
Recently, I've been playing the Terminal Attack. I think it. Wait, is that what it's called?
Oh,
The
yeah.
5v5. It was so
Yeah, I think
funny
so.
because I had one person on my team who was like really upset. They were like, "Oh no, you should listen to me." Well, they were using a bit more of aggressive language, but they're like, "Oh, you should listen to me." And then we just 4 of us went in for a fight. They stayed behind. They were the only ones left, and they just, instead of fighting, instead of helping us, they were just typing in chat aggressively stuff like, "That's what happens when you don't listen to me," and stuff like this. And what I found really funny is that at some point they said, that's what happens when you don't listen to the high rank player." And I just sat there, looking, holding tab, looking at the scoreboard, looking at the 0-0-0 score, looking at my highest combat score of the game, highest support score of the game, and highest objective score of the game, knowing damn well that the person telling me we should listen to the high rank has a golden rank, when I finished last season with a diamond. And that was my last game of Terminal Attack, which I will not be repeating. Because, oh boy, I can't go through. I don't like just making myself angry for no reason. Not the biggest
Yeah.
fun.
There was funny. I was just playing World Tour, and there was someone that was hanging back and wasn't doing anything, and they were going off on their own. And it was funny because it was another medium and they were light. So I literally threw 2 gas mines on them and shot them, so it killed them. And then we went and got the cash out just by ourselves, me and the other medium. And the other person was kind of like, they calmed down and they actually joined in. But It's like be put in your place. Stop being a jerk.
Oh, for me, I'm a light, so the only thing I do when I have an annoying teammate, I just wait for them to die, and then I just win. That's what I do. It's so annoying going from really high rank because, as I already mentioned this before, the finals
Yeah.
paradoxically incentivizes actually being friendly. If you're not friendly, you won't really get all that high because reviving teammates is one of the best strategies possible. And because of that, this is such a rarity. In high ranks, people are really nice and actually understand. I mean, obviously, there are certain personalities that are different, but most people are on average nice. And going from the sort of diamond, everyone's wholesome, back down and everyone just shouting and yelling and using the new typing chat feature to just bully each other. That's not a fun experience.
No. I don't think I've ever even seen the text chat.
Oh, I think you can only see it if you type a message in yourself. I'm pretty certain.
Oh, okay.
Which I'm honestly, in my opinion, that's a good way for it to work actually.
A volume.
Sweet. Did the guy just pass me? I think they did. Oh, interesting. Hey, it's the traveling one. Nice.
And right here we can already see a certain pattern. Not really important. What is important is the N times T.
Light fell to their
Because
death.
the
That's
absolute
funny.
temperature basically tells us the average kinetic energy of a particle.
They were running away from me. They successfully ran away.
There. Now let's go back to our E equals m squared t squared and define another unit called a Pascal, which is just
My favorite new item is the glitch trap.
Oh,
Thing is
because
super
the
annoying.
one that's awful. I rely on my grappling hook to get out of trouble, and it just kills me so often.
and again by length.
Yeah. And so I
And
put
again by
glitch
length,
traps everywhere
we get
now
this.
because
So
it's awesome.
S
Yeah,
cubed
it's-
is equal to m s squared.
It's basically a
t
stun grenade.
Or in other words,
It is, but
PS
it's
cubed
always
is
active.
equal
Proximity.
energy. And what is length?
You actually have
times
to
length
blow it
times
up
length?
yourself. It just
Well,
doesn't
that's
disappear. It's so
A
annoying.
volume, which means PV.
Oh,
is
you
equal
can't
to
use
E.
that anymore.
And if we merge it with the ideal gas law equation, there. So that's the thermal energy. Well, one of them at least. And right here we can already see a certain pattern develop. You see, first we started with classical mechanics and this equation. Then for electrical pattern develop. You see, first we started with classical mechanics and this equation. Then for electrical energy we took this equation and modified it to account for
I like your animations lately. They're awesome.
Yeah, if only I just didn't have volume everywhere and just they take ages to render. Such a long time. Like right now, I am three animations away from finishing the video completely. I have everything I have everything done. I can pinpoint the animations exactly, where they are, what each one should look like. But the only thing slowing me down is the render time. Shouldn't be that long now, though.
Yeah, only 5 minutes.
Only 5 minutes, plus, yeah, 5 minutes tops.
Yeah, these finals matches are super short. Been able to finish 2 in less than 5 minutes.
Yeah, it's just I've been able. Yeah, I mean, 5 minutes is a pretty short amount of time. My streams are also really short. I actually managed to squeeze in 5 hours of a live stream into these 5 minutes. That's how quick I am. free animations. Just free. Okay. It feels so weird finishing a video every single time because, like, I work on them for months, really often. Literal months, and then I just finish them in minutes. Them going from unfinished to them going to finish is just a matter of minutes. It feels off each time.
Yeah, I can't imagine your videos. That'd be tough.
I mean, you can't imagine them, but you can watch them. https://youtube.com/ make it happen. Subscribe. Patreon.
Don't you have the base 64 code memorized?
Tired. We wouldn't. I just realized I just spent 5.5 hours. Oh, yeah, 5.5 hours on a Sunday walking on the stream. Cool. That's cool. Remember to rest up on weekends.
Yeah. Hey, stop fighting him.
Oh yeah, it's way faster now. Alright, I turned off the thumbnail one. Oh yeah, I have to make third thumbnail. I keep forgetting. Okay.
See, first we started with classical mechanics and this equation. Then for electrical energy we took this equation and modified it to account for charge with this equation. For radiant energy we did the same thing except with this equation to account for the lack of mass. For thermal it's once again the same thing except with this equation to account for the statistical nature
Where
of
are they going?
thermodynamics, and there is a reason for it. You see, this equation just tells us the capacity for work in
Oh boy, I need to do all.
Ooh.
I won't be doing this. We'll need this one.
Anything new with you?
With me, not really. I'm just same old make it. Honestly, I really want to just. I've just been walking this video. That's it. That's all I remember in my life. I've been having the wildest thing happen in my dreams though recently,
What's that?
which is that I've been able to think in my dreams.
Okay, like lucid dreams?
Well, that's the fun bit. No. As in, just think. Like, you know how really often in your dreams, your train of thought is all over the place? And,
Yeah.
like, for example, you see a flying fish and you all of a sudden think, that would be tasty, and then all of a sudden you're eating at the kitchen table, something like that. Just a random train of thoughts, just thoughts completely reshaping your dream in a matter of seconds. Well,
Yeah.
recently I had a dream in which I turned my entire apartment into like a makeshift chemistry lab, and then I picked up a glass beaker, and I was like, and this was just in my dream. I just thought to myself, now that I finished making sulfuric acid for a video, I should restart working on the next chemistry video. And in my dream, I just spent like 3 minutes thinking, what should I make for this video? Then the dream just carried on, and when I woke up, I realized, holy shit, that was actually a pretty good idea. And I think I'll probably do it.
Good.
So, randomly in my dreams, I have these moments where I can just think, and I'm just thinking as if I'm awake, as if I'm just walking on stuff. It's a wild experience for me. There we go,
That's awesome. You know, they say that a lot. Your subconscious will process stuff while you sleep. That's why you should get good sleep if you're studying, they say. And you should study over a long period of time so it enters your long-term memory.
Lambda.
But
Next
there's a
up,
book that I read about speed reading and memorization. I don't know if you heard of that hypnotist that helped just a random person like win at Jeopardy.
I think I've heard that.
Have you ever seen that? So, anyways, he taught him a method for short-term memorization, and literally, it's really weird. You look at every page in a
For
book
thermodynamics,
at the
it's
center
really
and try to keep it all in
similar to
focus, and you
this
flip through all the
time it's
pages.
more
You read the synopsis, and you go to sleep. And this process helps like the data assimilate into your brain. It's kind of weird. I only tried it once and it didn't seem to work that well, but there's
Sounds
anecdotal
wild.
evidence that hypnotists can apply these things.
That is wild.
So your dreams, yeah. So your subconscious and dreams are powerful. So that's cool that you can get ideas even when you're sleeping. Open muscle started as a dream, actually.
But that's the weirdest thing. It's not that I can get ideas, because getting ideas from dreams, I feel like it's pretty normal. It's the fact that I can analyze them, and the fact that I can actually, well, think about them. As I don't know. It's just really odd for me. And the fact that I can't even figure out that these are dreams while at the same time clearly thinking about other things, that's just, I don't know, brains are wild. Okay.
Lucid dreaming is kind of fun because if you can realize that you're in a dream while you're dreaming, you can control your dream, and that's kind of fun. I like to fly
Yeah,
when
I
I'm
mean,
lucid dreaming.
It's tricky because you
But
have to
there were-
realize you're in a dream without waking up. And that's
Yeah, and it was funny because one time I failed at this, and I was walking on the sidewalk somewhere, and I'm like, am I dreaming? I don't know. Let me look at something complicated. So I'm like, let me look at the grain of the concrete on these steps. So I zoom in 2000% and look at all the intricacies of the concrete, and I'm like, yeah, that's too complicated for a dream. And then I woke up and I was like, dang it. But the fact that you could zoom in 2000% didn't even hit me until I woke up.
Oh, Link Sword said, walk on videos even in dreams. Yeah, I mean, I gotta get that productivity up, Speaking
Yeah.
of productivity, how close am I? 2 animations left. Okay, good.
Nothing else. That's because all energy is potential energy.
Alright, 2 minutes of footage left. Come on, make it. You can do it. I believe in you.
The throwing knives are super powerful. I didn't realize that.
They really are. They really are. And right when they became good again, I switched to a bow and arrow. Because that's just how I am.
Because on the training area, I was able to kill all 3 of the dummies in the front like super quickly. And that's kind of how I measure how much damage I can do per second for each weapon.
Throwing knives are really powerful because they are they have ever so slightly lower DPS than an average gun, but you don't have to reload, so you can just keep on tracking them. The right click sucks. It really
Yeah.
sucks. It's only good for entering a fight. So, hi the Despair, welcome.
Okay.
Welcome to live stream, in which we're making a video, and we're actually really close, like 5 minutes stops and the video will be done. So, glad you could join us for this momentous occasion.
To do war. All of the things I've described so far and more, like gravity and chemical energy, aren't connected by a solid line. They just all all the things I've described
Oh,
so far.
so this is kind of funny. So I make
In
that,
reality, it should be
I
kinetic
modified
energy.
that LED matrix, right?
Mhm.
And I showed my fiance when she came home, and I was like, "Hey, isn't this pretty cool?" And then it lights up the screen, and she was like, "Is that all that it does?" I was like,
Oh.
Yeah, but I'm controlling it, you know. And then she just laughed, and I'm like, "Well, that's hilarious."
That's
It's
so...
like because she like because I modified her phone broke, and I modified a Walmart phone to be the receiver for her cell phone, and she had to use it. Like I do stupid stuff like this all the time. So the bar is super high.
solid line
So the
between them,
fact
but
that I,
that's only because
hacked into
potential
a
energy is
device
a
and
bit of a
controlled it
misnomer.
completely is not sufficient anymore. The bar is
Reality,
too
it should be
high.
kinetic. It should be kinetic.
Oh, wait, this person says, I have good news. I just got accepted into college. I can finally call myself a physics major. Well, good for you then.
That's awesome.
The video looks very good, by the way. I'm looking forward to it. Yeah, so am I. I'm looking so far forward to it. In fact, I'm looking behind it, and I wish it would be there behind me. I just want it behind me already. I want to be done with it. Wait, that's wrong.
Soon.
Soon, yeah.
5 minutes.
5 minutes. Honestly, when I started this live stream, I didn't think I would actually go through with it. I thought I would just walk in the video, like I do every day. But then I started doing this a bit over and over again, and I realized that it wouldn't be actually funny to stop the bit, and so I just kept going. 2 hours, 3 hours, 4 hours, 7. Now we're approaching 6.
And it's only day 516.
Yeah.
It's not like 600.
Kinetic energy for all movement and static energy for everything else. That's because all energy is potential energy. All energy is just potential to do work. All of the things I've described so far and more, like gravity and chemical energy, aren't connected by a solid line. They just all influence each other. That's what existence is, affecting something.
If it's any consolation, I did edit for about 8 hours in the last 2 days.
So did I. One thing which I didn't appreciate actually is how quick I am when it comes to editing. Hungry Avner, I do believe, is working on the video right now, where they spend 4 hours editing, and I really didn't appreciate just how quickly I make my videos. Because in 4 hours, that's half a video for
with
me.
different models, different equations. We're trying to describe these with different
I've been working on
models.
I have a
different
lot of
equations.
different
We're trying to
recorders,
describe
audio
these
recorders of 2. I use OBS Studio to record sometimes, and then the in-camera card. So I've finally gotten decent at moving the
It's kinetic
camera
energy for all
and
movement
having decent
and static
shots.
energy for everything
So
else.
lining it up, I wouldn't say it's even editing, but it does
Static
take me a good
for
2
everything
hours
else.
to get
That's
everything
because
synced.
all energy is potential energy. All energy is just potential to do work. All of the things I've described so far and more like gravity and chemical energy aren't connected by a solid line. They just all influence each other. That's what existence is. Affecting something, leaving an impact. Light, heat, charge, movement. Light, heat, charge, movement. All of these things are completely different, and yet we use a single term called energy.
The ray
to
tracing is
describe
pretty
them.
insane in this game,
But
though.
that's it.
Yeah, Unreal Engine is
To
outstanding.
describe them with different models, different equations. All of the things I've described, different equations. We're trying to describe these completely different forces into a single coherent science. And that's what physics is. Physics is the answer to a question of what. What is energy?
What font are you using?
I think Myriad Pro. That's my default go-to.
What?
That's Adobe's default.
Yeah, I don't have anything specific. Fun fact, actually, I have one font on my PC, which it would be illegal for me to like. I could get sued for using it. That's fun fact of
Helvetica.
make it of the day.
Of what is energy?
Also, my
So I start off in
Also,
graphic
yeah,
design
that's
and logo design, so I heavily messed with fonts all the time and like the kerning and everything.
line between them.
But I hate
only
it now,
because
so I
potential
usually
energy
just pick one and stick with it.
yeah, that's Myriad Pro actually for me. For
Yeah.
me, it's similar actually, but a bit different because I haven't redone graphic design. I just worked a lot with graphic design, because I started my ad making adventure with making animations in After Effects for ads, and
Oh,
over
yeah.
there, I never want to actually. That's where most of my motivation comes. Making animation, making corporate animations in After Effects is the most boring, soulless, pointless, awful experience I could possibly imagine. It's not awful in a sense that it's like painful or something. No, it's just like the pointlessness of it. You can feel just how insignificant it is. And most of my motivation stems from the fact that I never ever want to do it again.
is a bit of a
Yeah.
misnomer.
And that's just pushing me forward. Oh, what, 6 hour long live stream of just editing on a Sunday? Count me
In
in.
reality, it should be kinetic energy for all movement and
Alright, there we go. Oh my god. Just this one thing. Okay. Okay. Alright. 2 more minutes to edit. Okay. Models. No, black room. Yes. Black room frames. 3. Input in.
you see, first we started with classical mechanics. This equation. Then for electric mechanics and this
I'm really so close. Just give me 5 minutes and I'm trying the finals.
Sounds good.
Really, just 5 minutes. It's
I'll just play another match.
yes. Play one more match. It's you have to be quick. It's 5 minutes, but one more match and then. Wait, do I really not have a single one with? Oh, you are not real. Please. Okay, this is thermal.
This equation. Then for electrical energy, we took this equation and modified it to account for charge with this equation. For radiant energy, we did the same thing except with this equation to account for the lack of mass. For thermal, it's once again the same thing except with this.
Yeah, the
equation to
news was
account
kind
for
of
the
crazy
specific
too.
nature of thermal.
You which one? I'm assuming you
I
mean.
don't-
I mean, there is one piece of news which is actually, well, shocking.
What's that?
Trump got the attempted political assassination. I think, well, so far of the decades, I would say. Which is, I would say, they are kind of, well, really awful, in my opinion.
Yeah. Yeah, it's just it's interesting because I had some people that said that that would probably happen. And I didn't actually take them seriously. I was like, well, they were right. For
Yeah, I
whatever
mean,
it's worth.
it's the, I don't know, like, what should I even call it? Polarization, radicalization, it's both of them. It's basically politics these days just run on hatred. So you're not voting for anyone because they're good, you're voting for them because you hate the other side. And if you hate the other side, then well, there are some people who, instead of voting for those they hate less, decide to just get rid of those they hate more. Fun.
Yeah.
Fraction s squared t squared. Compile as mesh. There we go. Electrical energy.
Oh my goodness. Well,
Another light team. This here. Central this. I'm almost there, almost joining in. Okay, just
No problem. We're winning.
it's good.
Take your time.
That's good. That's good.
Perfectly legible text.
Yeah. Yeah. 5 here.
Hmm. Okay.
Simple narrated. That's tough though. There's
It's a me.
yeah. Wow, I was not expecting a sudden change in tone.
Yeah. Kermit the Frog here. Or I can do Meatwad too.
I can only do Mickey Mouse, but that's mostly because of my high, naturally high pitched voice. P is equal to this. I've seen Les Miserables movie, and did you like it? I have not seen Les Miserables.
Les Mis. That's a good one. Jean Valjean.
Oh, I'm sorry, I hate the French with all my heart. That's give up for this one. This one pure white. There we go. Now all we need to do is just put them in the correct spots. So this one stays here, right? This one is E equals to QV, which is right here. This one, which is the one that's linking them together, so 0.2.
The Poor People movie.
Fuck.
I didn't say it.
I know, Happy did, yeah. That I just like right when you read it, I knew it was gonna be happy. It just sounds like a happy message. Got this. Okay. Alright, Tefta, so you won't believe it. But I just
5
need
more
like
minutes.
5 more minutes.
I almost guessed it.
Mechanics and this equation. Then for electrical energy, we took this equation and modified it to account for charge with this equation. Charge with this. Charge with this.
Helpful. This now. This was sort of enigmatic disease. I saw the video, but did not watch it.
Oh yeah, styropyro.
For charge with this equation. For radiant energy, we did the same thing except with this equation
Oops.
to account for the energy. We did the
Didn't mean to do that, but whatevs.
What do you most want to happen in the next few minutes? I want to finish the video. That's what I want to happen in the next 5 minutes. That's that's what I need to happen in the next 5 minutes. I can't take this no more.
same thing except with this equation to account for the lack of mass. For thermal, it's once again the same thing except with this equation to account again the same. For thermal, it's once again the same. For thermal, it's once again the same thing except with this same thing except with this equation to account for the statistical nature of thermodynamics, and there is a reason for it. You see, this equation just tells us the capacity for work in normal everyday objects like balls or cubes or whatnot. But in the realm of photons,
Energy
or charge,
video.
or average movement,
Dogmatism.
Now, what's dogmatism? I don't know the words which are this long.
Dogma.
Hold on.
Well, I know what dogma is. It's like a set of rules, specifically like in religion.
Arrogant, stubborn
Dogmatic.
assertion of opinion or belief. Why critiqued for dogmatism? Arrogance or positiveness is stating opinion. Am I? I got Alex's seal of approval on the last segment of the video, and the first segment is pretty simple.
there is a reason for it. You
My
see, this
button got
equation just tells us the
stuck.
capacity.
Get it, dude.
equation to account for the statistical nature of thermodynamics, and there is a reason for it. You see, this equation just tells us the capacity for work in normal everyday objects like balls or cubes.
It's crazy.
Or whatnot.
We
But
won.
the realm of like balls or
Just
cubes
give me
or
5 more minutes.
balls or cubes or whatnot. But in the realm of photons or charge or average movement, this isn't enough. Because this is only true for the classical model of physics. That's the thing. If you think about it, work is just a concept. That's it. Nothing more. We made up the concept of work to describe different behaviors of different
Sleepy's
things.
asking me,
Then
do
we
you
made up
think
the concept of
attention
energy.
is corrupt and makes people
We
bad?
made up
Yes. I'm a
I
YouTuber.
think-
Yes.
Well, yeah. If you social media platform attention does make you more egotistical. But there are people
Okay,
that
that's
it-
enough, Tefta. This is my live stream. Let's talk about me for a second. So you see,
no. But the thing is that there's a lot of famous people have drug problems. There's a reason because
We made
there's a
up the
lot to
concept of
cope
work
with.
to describe different
And
behaviors of
like
different
I was in a
things.
band with
Then we
someone
made up the concept
that had
of
over
energy to describe
10,000
how it works,
followers.
something
Like
can
it was a crazy
But
large amount.
We can't really simulate
And I
all
saw
of the
their
atoms
character
in a
degrade
kilobyte.
over a period of time. I wouldn't say that it can cause corruption. It doesn't necessarily cause corruption.
I call it the millionaire's dilemma. It's basically
Yeah, because it's like people will tell you that whatever you're doing is good, even if it's not good.
it's.
So you
I
have
mean,
to choose who you pay attention to.
I mean, there's actually a lot of problems there. Well, I mean, first of all, humans aren't really made to have this big of an audience. We can't. No one here can comprehend. I have 20,000 subscribers. No one here can even comprehend a number like 20,000. Human brains cannot comprehend this big of a number. And that's 20,000 living, breathing people, each of them having their own extremely complex lives. So that's the first thing. Another thing is, I call it the millionaire's dilemma. So basically, it's really interesting. It's basically, there was a study which found out that rich people have less free time, which is counterintuitive because you'd think that if you're rich, you can afford to have more free time. But the problem basically, the problem looks like this. When you're rich, your investments are larger in comparison. So, so a poor person, when they're going on vacation, they are losing, like, let's just say, $1,000 by not working. But a rich person, when they're going on vacation, them not working basically means them losing like tens of thousands, hundreds of thousands of dollars. And all of a sudden, this question arises: am I really willing to not spend but lose hundreds of thousands of dollars on a single vacation? And basically, because of that, the richer you are, the more effort, time, and the more effort and time you are spending on working, because the losses are greater. And because of that, people who are famous, it's the same thing. You're switching up the financial capital to a social capital. So because of that, people who are famous really often do things, go out of their way to keep this fame instead of actually using it to have a lighter, better life. So basically, instead of standing up for their
That's
values,
a lot of generalizations.
Oh,
would
but
say
I see it
that's a lot
happen.
of generalizations.
Oh, I see it. You see it happen all the time. Actually, it's just extreme pressure. So
No,
basically,
but what you're using examples of is a generalization, right? You're treating a whole group as if it's commonly known that this is what happens to them. But you would, in order to get that information, you would need a group of, let's say, 5 to 10 highly, wealthy people to pull from, I think, and then analyze their character. So your generalizations are for a topic surface level analyst of this, right? And so I think that inherently makes it very biased, what you just said. So I agree with the principles, but the fact that you generalize and assign a value to a whole group of people, I find to be a dangerous string of arguments. So I wouldn't ever use that type of argument myself.
Yeah,
But
I
I can
suppose
see
that's
what you're
true. I'm 6 hours into a stream. I'm talking nonsense.
Yeah.
Because this
It was
is
unscientific.
Yeah, got to hold you accountable to that scientific method.
That's fair.
But
saying
for,
famous people
like
should.
when you generalize, like a rich person might not have free time. Like, well,
That was
so
like just
there
the
are
thing, yeah.
some people that are rich that have less free time, right? And so of
No,
those
the-
small portion, is it a small portion of rich people that have that? Like what? And
No,
how do you
the
define
study,
rich?
the conclusion of the study basically was that the richer you are, the less free time you have on average.
That okay? So that's more interesting to me.
Yeah, as I
That the
mentioned,
more
that's
that you
because
make,
basically,
The
yeah,
less free time.
yeah, and the reason was precisely that. Like, also there was another thing: is that less free time you have, and I think the more worried you are about money. I think that was another thing. So basically,
I wonder what their numbers were. Is it like living
I
wage
remember.
analysis? How do they define rich? That would be interesting to know.
Oh, in this case, that was just because the point was when they said rich in this. I remember one example from the study. I don't even know where I remember it from. I remember one example from the study, which was someone who was earning. I think I remember it was a 5-digit number a month, and so basically the idea was they were more. They were more not attached to their money. I'm looking for what. Hold on, I'm tired. They were paying more attention to their finances, even though than a poor person might, even though they didn't have
Yeah.
to. And the whole idea was that it's kind of counterintuitive. Why do rich people care more about money if they have more of it, right? They don't need to care about it that much. But the thing is, the richer you are, the higher are your standards, and all of a sudden you're dealing with larger volumes of money. And because of that, you're putting more weight to it, and because of that, it all of a sudden becomes important, and because of that, you're all of a sudden becoming, more, not quite attached to it, but you're just counting each dollar. And so, but at the same time, your standards of living become higher, so your standards of what's necessary become lower, and so on and so forth. I was saying
Which is interesting because I bet you a lot of rich people would like that. Hey, that makes me sound like I work more.
yeah, oh no, it's not walking. It's more akin to I've just spent 6 hours walking on a 25-minute video trying to describe energy, so I'm really struggling trying to describe what I mean. It's not
So-
greed. Greed is not the word I'm looking for. It's the closest I can come up with. It's basically greed is the closest I can come up with.
Most people say that
For the
the
classical model
the
of
pursuit of
business,
betterment
that's the
is
thing. If you think
very
about it,
fun.
work is just
And
an
so
extra
if you
concept.
aren't improving, it's like a video
That's
game
it.
that
Nothing
you
more.
stop improving
When
and
we
you
made up
actually
the concept of
just
work,
get
we
worse
described
or stay
different
the same.
behaviors of different
It might
things.
not be fun
Then
to
we
play.
made up the concept
Oh,
of
but here's the problem, because you shouldn't think of it as improving, because in this case you're min-maxing, not really improving. If you're Goodhart's law, or just straight, or as I like to call it, misalignment, if you evaluate the quality of your life by the amount of money you have, then you'll start maximizing your life around how much money you have, and not around stuff like happiness and just improving in general. So in this case, if you think of your life, if you measure your life improving by the amount of money you earn, then instead at some point you'll have to choose between generally improving your life, being more happy, being wiser, stuff like that, and earning money. And then you'll pick earning money because that's how you measure it. Which means that you you know, you can end up earning more and more money each year, and at the same time being less happy, having less people around you, and, you know, fail at all the other measures which make life fun. Microsoft loves video consistent, so consistent before the corruption truth. Hold on. Are you saying famous people should curtail their aspirations at a certain point to be okay with losing profit / attention because they remain within a set threshold? It's not about that. It's about how how you basically have your own ideals, and at some point you will have to choose between your ideals and some portion of your audience. Mainly because statistically, there have to be people in your audience who disagree with some of your ideals. Otherwise, all of your audience would need to be perfect clones of yourself, which is, I would say, rather unlikely. And so at some point you will have to choose between your ideals and between portions of your audience. The larger you are, the relatively these portions remain the same, but in total, because of that, they become larger. And so, you know, it's easy to lose 3 followers over some of your values, but how easy is it to lose 30,000 followers over your values? Like in relation to how big you are. So someone who has there's
Or
money as
how about this? Losing one real friend life over gaining 1,000 followers.
Yeah, precisely. Like in this case, that would be a value, right? Friendship would be like a value in this case. And so at some point, you will have to choose. And whilst it's easy to justify, I feel like I shouldn't use money, for example, because it's much easier. So basically, losing $3, let's say you value your friendship. Losing $3 for that friendship is an easy decision. Let's say you earn, I don't know, $2,000 a month, and you will have to lose $2 over your friendship. That's an easy decision. But now let's say that you're earning or even more, 20 million a month. You're just insanely rich. You're Mr. Money. You just monopolized everything. And then you would have to lose $20,000 over your friendship. Relatively, those values are the same. What's more is that it doesn't even matter they are the same, because this won't really affect your quality of life. Even if it was $200,000, even if it was 2 million, your quality of life will remain the same. You'll still be a millionaire or a billionaire even. But yet it's much harder to for us, it's a much bigger loss. Even though this loss is meaningless in the end, your quality of life stays the same, like it's still $2 million. So that's the big problem. Basically, people think of it really often happens that that's just the way we think. That's the catch of of discounts. We don't think of discounts as like something we need. So when we buy stuff that's on discount, that has a discount, my goodness, I'm really having trouble. You have to understand, this is this is taking up a lot of my mental effort.
I was gonna say the punchline is, and that's why rich people don't have a lot of friends.
But I mean, but that's actually true. Oh, I think I know where I know this from. I think Some More News made a whole video about like psychological effects of being rich. I think it's called "Are Rich Be Okay?"
Isn't enough.
And it is scary. Where basically all of the studies find how rich people are less happy, have less social construct, and etc. etc. Which is really worrying, honestly.
If you think about it,
Well, being in a band was difficult because I got a lot of attention
we made up the
for
concept of
like
walk
being
to
the
describe
lead guitarist.
We made up
But
the concept of
luckily,
walk to describe
I mean, I
behaviors
wasn't
of
that good,
pigs.
but I did play a lot. But
We
I tried
made
to
up
make
the
sure that
concept of walk to
I
describe
didn't
different
let it go to my
behaviors of
head.
different
So I just
things.
didn't talk much. That was my solution. Just,
I mean-
just don't talk, and
You kind of-
people won't think you're a jerk.
I mean, you
They
kind of
won't know what you think.
killed 2 birds with 1 stone there, because didn't you also join as like a lead guitarist to overcome your fear of public performances?
Then we made up the concept
That's
of
why I
energy.
started doing public
Then we made up the concept of
performances
energy
was to
describe how
overcome my
more
anxiety.
something can
I
do.
had severe
You
anxiety.
can't really
So yeah,
simulate
and
all
that
the
really
atoms in a
helped
cube of
actually.
iron, and the intricate behaviors
helped a
of the
lot.
electron clouds, elementary
It helped
particles,
because I messed up on stage. Like
behaviors of
there's
the
this
electron
one
clouds,
pivotal moment where people actually were
and the
clapping
intricate behaviors of
to
the
the song I was
electron
playing,
clouds,
and I hit the
particles,
guitar on the music stand
ultramolecular
because I
forces,
was kind of
intermolecular
shaking,
forces,
and
so
it
on.
detuned the
That's
guitar, and I
why
had to stop
we
playing
invent modules
in the middle of the
to
song.
simplify.
And it was at that
Of
moment I
course, it
realized
is
the
so a
worst
classical
thing that could
model
happen
is
already
simple in
has.
simulating everything, but it's accurate for classical objects. And if you apply it to something like photons, it breaks down completely. There is no mass. That's why we need to modify it for photons.
Tefta.
So that would be the point of this video.
Are you done yet?
Energy
5 more
is the
minutes. Got it.
concept. Like
I
anything
think
else in
I'm actually
physics,
done.
different kinds of energy may be
Awesome.
treated differently, but
We
there
both
is
finished a video
capacity
today.
to work.
Yeah.
There is no better example than
Yeah, that's it.
That's
It
awesome.
always takes me by surprise because I never expected. Also, I would like to really thank you for catching my bullshit of being unscientific. I really want you to know I appreciate that. Because now the more I
Oh.
think about my argument, the more I realize it really wasn't
you
good.
see. First, we started with different kinds of energy.
Yeah.
may
Well,
be
it's just the
treated, but
generalizations,
they
right?
have
So
this
once I
capacity
hear
to
2 or
work.
3 generalizations, it's like, wait
there
a
is no better
second.
example
Like,
than
Yeah,
it's
it was
okay,
unscientific.
what is
but
potential?
well, it
Well-
it probably was scientific because you explained yourself. But
I explained myself, but
it's like
dry theory is not science. That's like saying
yeah,
we live in a simulation because, and then making an argument for it without. That's why research is important. The research part, gathering data and analyzing it. It was a theory without
Yeah.
data.
and I
think
hear a
it's-
lot of that, and I just make it a habit to stop people. It's like because if I'm having a conversation and then I hear like 3 generalities, it's like wait a second, because you just created a hypothetical world that I have to envisage, and there are 3 things that I don't necessarily agree with the first one. Then you hit me with 2 more. It's like wait a second, 3 generalizations. I'm having to expect this because when I'm listening to someone, I'm trying to imagine what they're saying and logic it out to see what I agree with and what I don't. And so those are usually red flags for me, like a generalization. And it's not as helpful in a conversation, but I'm too analytical, so don't listen to me because I would never get anything done if we use my rules to logic things.
I mean, a good
And I'm wrong.
like a good tell, in my opinion, is if someone has data, because there is nothing wrong with not having data. It's just that it's a very easy way to check if someone is being scientific or not. If they have data, then that's a clear sign they are. If they
Well, that's why I like
don't,
to
it doesn't
preface.
mean
Yeah. Like I have a friend that had an insane amount of followers, and I saw that ruin their character. It wasn't the only factor. So that's about the only person I know. And they had way more followers than you. I'm just, but
Well,
'cause they
don't
were
worry.
crazy awesome.
I just finished
Yeah,
the
they
video,
were-
so your sample size is about to increase.
That's right. That's right. No, but that's what it sucked though because I lost them as a friend because of it. Because all their
Oh.
followers were telling them that they were right, and they're not right. They're actually just becoming selfish.
That I'm really
And
scared
I
of
just said goodbye. Yeah, I just
that. Good
had
for
a few
you.
conversations with them.
I remember that. That's. I was actually really scared of that happening to me. I'm obsessed with science. I'm a science cultist, as I keep mentioning. I was really scary. I was really
Cultist.
scared with that happening to me when the addition to quantum mechanics really
12,000.
blew up, and I remember back then I said that like.
Yeah.
I was really scared of that, but fortunately, I have a nice way to check. Actually, in my case, I have a pretty easy way to check because I know for a fact that I have a group of people around me who are scientifically minded and who are really good at thinking, analyzing stuff. If they tell me that I'm becoming a dick, then if I'm becoming a dick, then I have no way to check myself if I'm becoming a dick. If I'm becoming a dick,
Yeah.
I'll think of myself as awesome, and thus awesome people can't be dicks. So an easy way for me to check is just to see if other people think of me as well.
And I think that's how popular or maybe rich people do. If you have an entourage or a group of people that you trust their opinions of, that can help you have a compass, right? And so that's why I value my good friends, is because I want to know if my compass is facing the right direction. Even though my friends may not share all of my opinions, I at least, each of them gives me perspective, right? If that makes sense.
Yes.
And so I also value having an array or differences amongst my friends' opinions, like ideologically, politically,
That's actually
however.
another problem you really often see, how some people become famous too fast. And
Yeah.
that's, at least from what I've seen, when some people become viral, it really often has an extreme negative effect on them because they just can't deal with the fame.
Same with winning the lottery.
Yeah.
When people win the lottery, a lot of times they'll be bankrupt soon after. It's funny that they're so similar, popularity and money, because they kind of go
It's
hand in hand.
financial capital and social capital. If you have
Yeah,
one,
yeah,
you
there you
can
go.
easily get the other.
Yeah, you can buy one with the other.
I mean, you
Literally.
can buy
can buy
fame.
money
If
with
you're
followers.
famous, then you can get rich easily. That's okay. There we go. I'm done. It finished. Done. There. It feels off. It always feels like I'm forgetting about something, but well, I am. Make It actually has 12,000 subscribers if we think about it. What? I don't even. Make It's degradation from fame is inevitable. I sure hope not. Haha, not if I keep losing subscribers like I have for the past 2 weeks. Hopefully this will get them back.
You lost subscribers?
Yeah, well, I mean, my... Hold on, let me actually check the stats for this. So, my average subscribers for the past 3 days has been a gain of negative 18.
Oh no.
2 days ago I lost 5, yesterday I lost 2, today I lost 11. And that's net, that's all net. So, well, hopefully this will get them back.
That's right.
What is energy?
Light, heat, charm. For now, this time.
I have 15 views on my video, so if you beat 15 views in 1 hour, you're better than me.
That's the only thing I have is YouTube. Just let me have it, please. Let me have this one thing. All right. Description top 6. Yeah, it's definitely going in top 16. This is one of my favorite videos already. Definitely in top 16. Oh, YouTube has this one really nice feature now. I don't know if you have access to it, because for some reason
No.
YouTube gives.
I don't. I don't know what it is. I'm gonna say no. I don't. See, this is you sticking your thumb up at me. No, I'm just kidding.
No, I know why
what is
YouTube
it?
does it actually. That like sometimes they give access, a feature of uploading multiple thumbnails at the same time. So I can basically
that's
upload
cool.
3 different thumbnails, and then YouTube is showing them basically showing them to different people at different times, and then you can get stats for which thumbnail performs best actually. And
Oh,
that's
cool.
really helpful for me because I don't like clickbait and I don't actually care about making a good enough thumbnail. So I just make 3 random ones, and then one of them should end up, walking out. That's the hope, at least. Yeah, you can see it on stream if you want. I can throw it there. Test and compare up to 3 different thumbnails, and then I just open it right here. Hot thumbnail 0, 1, and 2. File is bigger than 2 megabytes. Son of a, make it.
Well, I've destroyed the practice range sufficiently.
Oh, hell, I can finally play the finals. Took me long enough, didn't it?
Yeah.
Because 5
Even
minutes.
The trees are dead.
Took me like 5 minutes.
It's actually hard to blow up everything.
Have you seen the Expanse Psychic? No, sorry, no, not really. I've been busy. There, these are the 3 thumbnails. Sick. And now the chapters. This is the... Okay. So, 21 seconds, that's the intro.
I use AI for my chapter markers.
For me, I have different, like, styles of animations for different chapters, so... I kind of have them scripted into the script.
So you have the timestamps.
Well, not the timestamps, on the vague idea.
Oh,
7:39. Positioning in between them. There we go. Actually, not that long of a video. $13.51.
yeah, that's one of the difficult things about like money or popularity is you get acclimated to whatever you have. So there's always the saying that I like to meditate on is like, what's the difference between complacency and contentment? I've brought it up a couple of times, but to be content with what you have, but not complacent, like not wishing to change. I don't know. I find it zen. And maybe you'll have to keep me in check if that $1 billion idea turns out to be a $10
Since
billion
energy
idea.
is conserved, there isn't actually a way for us to lose this energy,
I'm
and that's
gonna
why it got
shame you into donating charity.
Use the clarify thing.
I'd be
Don't
like,
need a
make it,
previous
I already
equation,
own
electric
4.
charge.
Make a fifth one. The slice of... We need to
Yeah.
expand the slice of
We
pie.
have a give you some energy. For every 10 called energy
Physics.
to movement. All of these things are completely different, and
I
yet
kind of like this one,
we
I'm
use
gonna
a
lie.
single
Well, I
term
hate it at this
energy to describe
right now, because...
But that's it. To describe them with different models, different equations, we're trying to describe these completely different forces into a single coherent science. And that's what physics is. Physics is
Checking
the answer to a
17%.
question of what
What is
is
energy? And
And
then...
so that's the video I really to make. Literal weeks of decide what the new make in the corner should look like. And Discord. I also have a Discord server in case you'd like to join. Anyhow, subscribe, like, and I suppose that'll be it. Thank you everyone so much for watching. Now, and have a great day.
The upload was suspiciously quick.
Bye.
I don't know if I screwed
They
something.
hacked your computer. They already had it before you.
I mean,
even rendered it.
I'm streaming. They were like, "Oh, you know what you're streaming? Might as well send it over, right?" No, we've seen your stream of making the video. Okay, everyone ready? 3, 2, 1, public save. Oh, I have to wait for the checks to be monetized. I don't care about monetization. Just publish the thing there. Hold on, let's start the timer. Google timer. Let's start. How many views in an hour I need to get?
Yeah, but don't you want to wait till it renders the high def?
Ah, it's fine.
Okay.
Google stopwatch.
But if you set as an instant premiere, sometimes it can be low quality.
All right, we're starting the stopwatch. Okay, hold on. Let me. Oh yeah. Also, I should technically switch it to the next day because I've been streaming over a day. So hold on. I mean, I'll still be on the voice, I suppose. So suppose you know I have to hold on. There we go. No views. 44 seconds. We make thumbnail for the second stream. And also, so yeah, that'll be it for today's live stream. Thank you everyone so much for watching and have a great day. Bye.